So we have done with your D block chapter. Now let us come back and start one organic chapter, that is your amines. I think with this your organic part will be done. Only polymers will be left. Maybe that's very easy chapter. And chemistry in everyday life. Okay, that would be a general topic which I'll be dealing in a different way. Yes. So when I have to come to amines chapter, the easiest chapter of organic chemistry, let's see what are we going to learn in amines. So in amines, we are going to learn about the structure of amines. I'll tell you what is a hybridization, how should you remember, what type of questions are asked. After that, you're going to study classification, nomenclature. As I said, once I complete the syllabus, all the functional groups, nomenclature and classification would be done under one single platform. I'll pick up a whole tabular column and make you all practice. Done. After that, when I come to the preparations of amines. Now in amine preparation, we are going to study about reduction. What are we going to reduce? We are going to reduce nitro group, nitrile group. Nitrile is cyano. And amide. This is amide group. So I'm going to show you the reductions of all three and finally prepare amines from that. We can also learn the preparation of amine by a process called aminolysis of alkyl halide. I'll also be teaching you clearly how to remember that concept. So aminolysis. Then fine. Addition of ammonia around this. Okay, that also we'll do. Then we are going to learn one name reaction, Gabriel thalamide synthesis. Very, very important reaction. And also we're going to learn Hoffman's bromamide degradation reaction. So why did I label this? Because mention this. Whenever you write an index, you very well know from which chapter you're getting the name reactions. So remember, for preparations, 1 reduction, 2 aminolysis, 3 Gabriel thalamide, 4 Hoffman bromamide. Once I complete all this, okay, you will be doing some questions on physical properties. Okay, that's general simple thing. Then physical properties I have not mentioned here. After physical properties, we are going to come the main concept of the chapter. We are going to study the chemical properties of amines. Under chemical properties, you are going to study the basic character of amines. We'll be comparing alkyl amines. We'll be comparing aryl amines and alkyl amines. I'll be showing you what is the basicity of ammonia. All these concepts, question by waste, I'll be dealing with this in basic nature. After that, I'll be also teaching you the process of alkylation, that is addition of RX, acylation, RCOCl, carbylamine reaction, formation of isocyanide compound, and reaction with HNO2. I'll show you all the possible reactions of HNO2 and with benzene sulfonyl chloride. ArSO2Cl is benzene sulfonyl chloride. I'm going to show you how your amine is going to react or combine with all these and form different products. I'll be making it in one platform along with the expected questions or FAQs. After that, I'm going to directly go into aniline, aromatic amine, and where I'll be showing electrophilic substitution reactions. In that, I'll be teaching you about bromination, nitration, and sulfonation. I'll also be teaching you what are the different variations in this. Yes, done. After that, I want to come to a topic called BDC. Okay, BDC stands for benzene diazonium chloride. So BDC compound, basically that's a small topic, but mostly questions are asked from that topic. So I'll be teaching you how can I prepare BDC by a process called diazotization. Basically BDC formula is ArN2Cl. So I'm using the process called diazotization. Azo means N2. Done. Now, in chemical properties, we'll be studying about coupling reaction, Sandmeyer's reaction, and Gattermann reaction. Remember, in preparations, you have 3 name reactions. In chemical properties, you have again 3 name reactions. Coupling, Sandmeyer's, Gattermann. After that is over, I'm going to show you, I'm going to replace your amine group with fluorides, iodides, hydrogen, hydride, OH minus and NO2 minus. I'm going to show you 1, 2, 3, 4, 5. What are the different products formed? After I'm done with that BDC, because BDC try to study under one section. The whole thing of BDC is important. And finally, we'll end up with uses that you can do, I believe. So this is your complete amine chapter index. Please remember, again, I'll be doing it in a detailed way. Don't be in a hurry to say, ma'am, please complete the syllabus. No, my concept is not to complete the syllabus quickly. It's basically to make you understand so that you'll be able to write in the exam. Don't worry, your syllabus will be done by Jan 30th. We will complete it comfortably and you will write your chemistry paper very well. So please note the index. chapter. We've already done the introduction of your amines chapter. Now in this particular chapter, I'll be dealing with the whole concept in a different way. So please do watch the videos on regular basis and keep noting the reactions. I'll be showing the link between different compounds of this chapter. Now here in this chapter, for your prescribed syllabus in amines, we are going to study about different compounds like nitro compounds. So it is RNO2, okay, an alkyl group with nitro. We are also going to study about compounds like amines. So in that amines, R and H2 is amine. Apart from amines, we are also going to study about compounds like cyano compounds, RCN. With that, we are also going to study about compounds like amides, right, RCO and H2. So these are the different compounds. We'll be learning different conversions, how to learn. This time I'll try to make it a bit easier for you to remember. Yes. So in amines chapters of how basically are these amines and what are the types of amines, we'll see. Now I have to take, now first I'm going to take ammonia. Yes, NH3. We very well know ammonia, nitrogen has lone pair of electron, isn't it? Now 1, 2, 3, 4, 5, 6, right? 2, 7, 8, 2 more lone pair of electrons. Now this ammonia, I'm going to add an alkyl group R and remove one H. One H from here, one R from here. What do I get? N, 2 hydrogens and R. This nitrogen with one alkyl group and 2 hydrogen atoms is called primary amine. Done. Now the same primary amine, I'm going to add one more alkyl group and remove one more hydrogen. This time this hydrogen comes out and this alkyl group goes and attacks. This is called nitrogen with 2 alkyl groups and lone pair. Now here there is one alkyl group, primary amine. There are 2 alkyl groups, secondary amine. The same thing, I am introducing one more alkyl, removing one hydrogen. So this hydrogen this time. So this alkyl coming and attacking. So now nitrogen is occupied by 3 alkyl groups. So nitrogen with 3 alkyl groups is called tertiary amine. We also have a quaternary amine, quaternary ammonium salts also. We'll be doing that also. So now this is how your amine is formed. Now when I have to learn the structure of amine, how should I learn the structure? Simple. Now if I am going to take the structure and explain anything, not a problem. I'm going to take that structure and let us start. Whenever you're learning structure of any particular molecule, important thing, the criteria for learning or explaining the structure are 3. First one is you're going to explain what is the hybridization in that. Point number 1, you're going to explain what is the shape of the molecule. After that, you'll be explaining, you should have all these are criteria for explaining the structure. You'll also be explaining what is the bond angle for that particular thing. If you have any lone pair of electron, explain about the electrons. So these 4 criteria will complete your explanation. Now, whenever you're taking tertiary amine, now I picked up tertiary, anything you can pick up. Now suppose if I am taking the tertiary amine, so done. Nitrogen with lone pair of electron with 1 R, 2 R's and 3 R's. How is the structure looking? Now basically your nitrogen is in the center and you have a lone pair of electrons here. This is what I showed, isn't it? Done. Now to this nitrogen, the 1 lobe, because 3 methyl groups, isn't it? 2 lobes and 3 lobes. From here your CH3 is linked, your CH3 is linked, your CH3 is linked. Done. From this nitrogen, just 1 bond. From this nitrogen to this one, from this nitrogen to this one, and from again from nitrogen combine from this nitrogen to this one. So what is the shape you have got? The shape of the molecule in this, I am not perfectly drawn, but the shape of the molecule when I observe, the shape is pyramidal in structure. Pyramidal. All lone pairs, so sorry, all single bonds, so it is sp3 hybridization. Now when I have to see the bond angle, now what are you observing here? You're observing lone pair and bond pair repulsion, correct? So what does this do? This lone pair and bond pair repulsion, because of this lone pair and bond pair, it's going to push in, or that's going to just decrease the bond angle. It was like this. Because of this repulsion, the bond angle reduces. To what extent? The bond angle reduces to 108 degrees instead of 109 degrees. Yes. Now electrons, do we have any lone pair of electrons? Yes. It has a lone pair of electron. Lone pair of electron. Yes, because of this only the main concept, isn't it? So this concept is making or reducing the lone pair, reducing the bond angle. That is what we have mentioned. So this is your whole structure of your ammonia, or not ammonia, it is trimethylamine or tertiary methylamine. You can write for anything, but what will happen if you write this one here, this in H and H will be there in methyl. If you write this compound here, this will be H and 2 methyls. So 3 methyls have already written. Right, so now let us start with the chapter. Now I said I'll be doing the chapter in a different way. Now I'll first give you a link about how to remember the chapter. Now basically in this chapter I said it's composed of, we're going to study about nitro compounds, you're going to study about amines, and we're going to study about cyano. So always remember, whenever you are given a nitro compound, nitro is first converted to amines. Amines is then converted to cyano compounds. Remember this. And cyano further you can. So this is your sequence. Always remember. How should I go about this? Now first, let us prepare nitro compound. How am I preparing nitro compound? Suppose if I'm going to take CH3, CH2Br. Okay. This is your alkyl, haloalkane. So instead of CH3, CH2Br, I am writing as RBr. Not a problem, isn't it? Now to this RBr, I am going to introduce silver nitrate. Right. So here, important, why are we adding silver nitrate? Because silver nitrate is going to come out as a precipitate, AgBr, where we have studied in grade 10. It is used in the photographic technique, isn't it? So silver nitrate basically is going to come out, a precipitate is AgBr, but important, this condition or the solvent used should be alcoholic. Done. Now first important thing, Ag and Br comes out. So what do you get? AgBr as a precipitate. What is left? Now here NO2. Now see, I have prepared NO2. Yes, simple. Now after preparing NO2, now I have to prepare amines. Simple. Now what is amine formula? Amine is RNH2. Okay. Now how is this prepared? What is the difference here? This is also R, this is also R. This is nitrogen, this is nitrogen, but extra is hydrogen. So what made, from where did this get hydrogen? Yes, removal of oxygen and addition of hydrogen. What is that process called? Reduction. So what is going to perform that reduction process? Reducing agents will get that thing. So I'm going to add a reducing agent like SN plus HCl, metal acid we call. We call it as metal acid. It can be Fe plus HCl also. So SN plus HCl, metal acid, Fe plus HCl, metal acid. I'm going to add this. When you're adding this, see here, O, oxygen is removed and your hydrogen is added. Got it. Simple. So most important thing, this. Whenever you see this in the paper, that means the examiner wants you to add hydrogen and remove oxygen from that, because it is a reducing agent. Done. Now from amine I have to convert into cyano. So what is cyano? Cyano is RCN. No, it can't, we can't directly convert the cyano. See what is the procedure. First important thing, RNH, there are two ways. One, I can get it from amine. One, I can get from RBr also. Yes. So when I have to get it from amine, I have to use a list of steps. Yes, important. Now for that step, first thing which you are going to do is, first always, amines cannot be directly converted to cyano. We are going to first use nitrous acid. Remember, what is this nitrous acid? The role, it is used as a reprotonation agent. It is a reprotonation, means it's going to add a proton along with that OH group in that. So what does this do? This is going to convert, yes, your amine group into an alcoholic group, right? ROH. I get an alcoholic group. Reprotonation is adding that. Now from this alcoholic one, you have got alcohol. Important thing, you have to convert it into iodo compounds first. So what am I going to do? I'm going to add phosphorus in the presence of iodine. When I add phosphorus in the presence of iodine, this is going to become Ri. Now further, since still it's not complete, then I'm going to introduce KCN to this. Yes, so alcoholic KCN. When I'm adding Cn to this, look here, this is your C minus, this is your I minus. I is replaced by this cyano, I get RCN. This is how I prepare cyano group. Now one more option, easiest, ma'am, I can't remember so much. So RBr, if you treat with KCN, alcoholic also, your CN gets in, your Br is out. So you get RCN plus KBr. This is also one procedure. So why am I teaching this? Because when they ask you to convert alkyl bromide to cyano compounds, this is one conversion. If they are asking you to convert nitroalkane to cyanoalkane, this is one conversion. So when you learn such type of things, you know, at a stretch, it's easy. So now what should you do? Please practice this. Write in your books clearly. Practice this more number of times. What concept should you remember? Nitro to amines. Amines, then after that amines can't directly be converted. It will go to this step, these steps, then finally form cyano groups. Yes, so let us come back and start with your preparations of primary amine. That is your chapter main content. Now whenever you're learning this chapter, remember what am I going to do? I'm going to teach you the conversion also. I'm going to teach you the preparation also. I'm going to teach you the chemical properties also, so that everything is in the same page. So whenever you're watching this video, because I upload it on daily basis, if I write amines, so take one page, okay, take one register, both the sides of the page, note the whole reactions, all the reactions which are linked to amines. Okay, what is the use in the exam when you are trying to learn? Everything will be under those 2 pages or 1 page based on your handwriting. So that is how I'm going to teach you. Even the conversions will be there. So now when I have to learn primary amine, first important thing, you are going to take an alkyl halide. To this alkyl halide, you are going to add silver nitride, which is alcoholic medium. Why do I add? Because this will precipitate out. When this is precipitating out, you get CH3, CH2NO2, nitroethane plus silver bromide. Done. Now I said always nitro is converted to amino, after amino only cyano. So this nitro is going to get converted to amine. How? I have to take out this oxygen, I have to add one hydrogen to this, which will get me the hydrogen. Reducing agents will get me the hydrogen, isn't it? So your reducing agents can be both. Just see, it can be SN plus HCl, metal acid, or it can be lithium aluminium hydride, both reducing agents. So what will these do here? Important, try to add 6 hydrogens. I am writing 6 hydrogens directly. Why, ma'am? Why are you directly writing 6 hydrogens? Because just see, for this how many I need? 2 hydrogens. Let us write that. So both will give the same product. In the paper, if you see these 2 agents like this, okay, blindly remember the examiner wants you to add hydrogen to that. So reducing agents. So now CH3, CH2, NH2. How many have gone? 2 have gone. Still I have 4. So 4 will come out as 2 water molecules with this oxygen. Oxygen is 2, 2. Hydrogen is 4, 4. Plus 2, 6. Done. Now I prepared primary amine. This is your preparation. Now this primary amine, why? Just see, when I am going to introduce 3 important compounds. One is, this reaction is called acylation reaction. This reaction is called benzoylation reaction. This reaction you are going to add, or we call it as Hinsberg test also. Okay, we'll see that. Hinsberg reagent. Hinsberg's reagent. Now, what actually is this acylation? Acylation is addition of CH3COCl, acyl group. Benzoylation is addition of C6H5COCl. That is your benzoyl group, benzoyl. Hinsberg reagent is C6H5SO2Cl. This is Hinsberg reagent. Okay, let's see. Now what will happen in the paper? If they give you primary amine, you have to add this and see, just addition only. Now let me write the reaction down. I am taking this and this first. your CH3, CH2N, one hydrogen here, one hydrogen here. I'm going to add acylation reaction. Cl, try to write it on this side. C double bond O and CH3. As soon as you add acyl group, HCl is eliminated. Now when HCl is eliminated, this group goes and joins to this group. So I'll write this as C2H5. Not problem, right? So now NH. This is C double bond O. This is CH3. Now what is this compound? This is called amide. Let us write the product and name the compound. So I'm writing that product here. C2H5 NH CO CH3. Now how many do we have? Here you have ethyl group. Here also you have ethyl group. How to name? Both are in the terminal corners, means terminus. N comma N. Diethyl. 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 Yes. What amide is it? Ethane. E-A-T-H-A-N-E is ethane. No, take out that E and add amide. Ethanamide. That's it. Simple. This is called acylation. Now let us do benzoylation to this reaction. Same procedure. So in benzoylation, what is the difference? Here you have your benzene ring, isn't it? C6H5. Okay, your benzene ring. Same procedure. Minus HCl. Join these two. C2H5. NH. C double bond O. C6H5. Amide linkage. Yes, now let us write the product here. C2H5 NH C double bond O C6H5. Right? So now what is this compound? Now N. This is phenyl. Phenyl ring, isn't it? Not benzyl. Phenyl. One hydrogen less. So phenyl. Right? Now ethanamide. Ethanamide. Why amide? Because this group. Now let us write Hinsberg reagent. So in Hinsberg test, what should I take? I am going to pick up CH3, CH2, NHHH. I mean, take this Hinsberg reagent. How are you taking? You're going to take chlorine in this side. S double bond O, and your benzene ring. Eliminate HCl and form the product. What product do you get? C2H5 NH S. Simple. Let us write that product. Yes. Now, what is this compound? This compound is benzene. This compound is sulfonamide because sulfonamide. Okay. Now, this is ethyl, right? Now, you can write ethyl, benzene, sulfonamide. Benzene, sulfonamide. Sulfonamide. Simple, isn't it? Now these are the complete reactions. Okay, this is one set of reactions which you can study directly. Now remember, now we have done this, isn't it? Suppose in the exam, instead of this, right, if something else is given, what else is given? Let us erase this. The same Hinsberg reagent reaction, I'll write it in different. Here, what did we take? We have taken a primary amine. Now, suppose if I take an amine, that is your secondary amine. Okay. Now, that secondary amine, let me take C2H5. Let me take C2H5. Okay. I'm just taking C2H5. You can write like this also if it is confusing. C2H5. Not a problem. To this, I'm going to add Hinsberg reagent, that is Cl, S double bond O, and your benzene ring. Same story again. Take out HCl and join C2H5N, C2H5, SO2 and benzene ring. This is one more modification of this. Instead of primary amine, I took secondary amine, nothing else. Now tertiary amine can I take? I can't, because there's no replaceable hydrogen atoms. So this, how do you name this? You have two terminals, you have two ethyl groups, N comma N. Diethyl, sulfonamide. Which sulfonamide? Benzene sulfonamide. Benzene sulfonamide. Okay, I don't have place here. So benzene sulfonamide. Okay, now remember preparations 1, 2, 3, 4. All 4 at one page. Please write it like this only. It is easy for you to study in the exam. So now let us come back and start with the next set. The same thing again. I'm using the same ethylamine and we are seeing further 3 more reactions. So now same story. You're taking alkyl halide, you're adding silver nitrate, you're getting nitrobenzene. One reduction is giving ethylamine. Now to this ethylamine, if in the exam, if they give you such reactions, right? Now simple. This is your chloroform, and there's a difference between, please see, there's a difference between CHCl3 and CH3Cl. Lot of difference. This is chloroform, this is methyl chloride. Now what is this compound? Chloroform. CHCl3 is chloroform. Now in chloroform, if you are in the presence of a base, potassium hydroxide, strong base. Now this, if you are treating amines with chloroform and potassium hydroxide, that particular reaction is called a carbylamine reaction. Remember that. Or it can also be called as Hoffman's isocyanide test or isocyanide reaction. Okay, let's see again. Whenever you see chloroform combination with KOH, yes, that's also called, this reaction also is called carbylamine test or reaction. How do I write in words? In carbylamine reaction, okay, when a primary amine, okay, let us write that also. How should I write? Carbylamine reaction or test. Now, what is happening? When primary amine is treated with chloroform. What is chloroform ka formula? CHCl3 and a base. Here we are going to take KOH. Yes, so 3 moles I have taken. KOH. Yes, it forms an offensive smelling compound. That is isocyanide. That reaction is called carbylamine. Okay, I'll also explain you the carbylamine reaction. As of now, simple, remember. This, when it is treated with chloroform KOH, nothing to do. Write the whole thing like this. Okay, let me write it as R for you better. NH2 will turn into a compound called NC, which is a bidentate, both the sides. It can form C and NC because it is a bidentate like that. It's getting attacked to a highly electronegative nitrogen atom. So this is called isocyanide compound or carbylamine reaction. Along with that, you have 3 potassium, isn't it? Now 3 will come out as 3 KCl and water molecules will come out as 3 water molecules. Once again, amine, when you see with chloroform and KOH, convert amines to isocyano compounds. This is called carbylamine test. Amine to NC. Amine to NC. So once again, somewhere you will remember NH2 to NC is carbylamine test. Along with the KCl in water. Done. Now what should we do? Now I am going to take the same amine, and in the paper, if it is given as HCl, okay, what to do? Don't get confused. Nothing to do. With HCl, they are going to form salts. What salt? Just see. Now just take this HCl, add to this. CH3, CH2, N. Now NH2 plus H becomes NH3, Cl plus N minus. What is this compound? You have two carbons, isn't it? So N-ethyl ammonium chloride. Again, N-ethyl, I don't have place to write, I'm just explaining N-ethyl ammonium chloride. Now, suppose, instead of primary amine, if I have, okay, instead of this compound, now I have carbyl amine done. Primary amine, this is my ammonium chloride salt done. Instead of primary, if I have a secondary amine, let us see. Now C2H5, C2H5 and NH. I'm going to add HCl, okay, to this. Same story, isn't it? Now this becomes C2H5 taken twice, NH2Cl. Done. Now what happens if you don't have any hydrogen group for tertiary? See what's going to happen. This whole thing, I'll write it as 3 times. It's going to form then 2, it's going to add to this H and form Cl. NHCl minus. So tertiary ethyl ammonium chloride. Same. This is primary, that is ethyl ammonium chloride, secondary ammonium chloride, tertiary ethyl. Here secondary ethyl. So tertiary ethyl ammonium chloride. So it's going to form an addition compound converting into salts with HCl. Okay. So amine, basic, acid combination forming a salt. So remember these reactions. This is a second set of reactions. And now let us come back and learn the next set of reactions for the same amine. Primary amine only, I am comparing different sets, common types I am trying to give you. Same story again, alkyl halide, silver nitrate treated, you will get the nitroethane. From that, nitro are converted to amines always. So I will get this. Now what happens if I take this amine and I am going to perform a reaction called aminolysis. Okay, very important reaction in this chapter. Aminolysis. Right. So what actually is this? See, lysis means cleavage. Which one is cleaving? Amino group is cleaving. So what actually is aminolysis means? Suppose if I take an example, first I'll take a general example, then I'll go to the specific examples. Now in general examples, if I'm taking a primary amine RNH2 and I'm adding right to this particular thing, let us assume I'm taking an amine, I'm not taking the actual ammonia until now. Let's see. To this I'm going to take an alkyl halide, add an alkyl halide. So first what is going to form, just see. Okay, let us write X this side, R this side. Just general thing. Hydrogen, one hydrogen here. First important thing, HX comes out, minus HX. This whole group comes and adds to this. R, nitrogen, hydrogen, one more R group. Done. Now to this I am going to add one more RX. I am still not going into the aminolysis reaction, just see. One more HX comes out and you get R, N, R, R. Still one more RX combines. Yes. Now where is this H to remove? Just see what's going to happen. It's going to add to this nitrogen, like it's going to form a compound called R3. No, it is R4, isn't it? Sorry, it is R4. NX, quaternary ammonium salt. This is the main concept. It's going to form quaternary ammonium salt also. Now let us start seeing the examples. Now suppose I am going to take two important examples. First one, the first example is, just take ethylamine, the same thing. C2, okay, not ethylamine. First I am going to take ammonia. For aminolysis, the concept is the same, but here I am going to add ammonia. The addition of ammonia to alkyl halide is called aminolysis. Okay, what is aminolysis? Aminolysis is the process of addition of ammonia to an alkyl halide. It can be ethyl, propyl, anything but halide, alkyl halide. So when you are adding, the first important thing, what is going to happen? There are 3 hydrogens. In these 3 hydrogens, okay, I'm writing like this. 1 H and Cl comes out. What do I get? I get a C2H5N, H and H. Done. So what is this? Ethyl or ethanamine. Ethylamine. Now to this thing again I am going to add one more. Now amine is already entered. Now I am going to add C2H5Cl. One more. Same, see here. I am adding this one RX. That now C2H5Cl. Now again 1 HCl and this one comes out. So every time you are trying to add to this, what do I get? I get C2H5 and C2H5 and H. Diethyl ethanamine. Now to this particular thing you are going to introduce one more C2H5Cl. HCl comes out and you get N C2H5 C2H5 and C2H5. Triethylamine or ethanamine, triethyl. 1, 2, 3. Triethylamine. Right? So this is your aminolysis. Now let us take one more. Here, what did I take? I took alkyl halide. Now if I am going to take aryl halide, RCH6. Same story, aminolysis. You are going to add, take out hydrogen, take that hydrogen out, first hydrogen out. Every time ammonia is adding to alkyl halide, that is your aminolysis. Okay, now C6H5, N, your hydrogen is one side, HCl has come out. Yes, done. NH3, no? 2. Now again to this you are going to add one more aryl halide. This hydrogen HCl comes out and you are going to get a secondary compound with 2 aryl groups and 1 hydrogen. Now further you are going to take this aryl halide, introduce one more to this because every time you are trying to replace, isn't it? Finally I get this compound. Further, see here. Now this is with your triethyl aminolysis. I've taken ammonia to primary. Here you have got aryl compound 3. Further, if you take, now I am at this stage. This is the stage here. This is the stage here. Suppose further if I take and add, I get this salt. I get this salt. Simple. So this is the aminolysis process. Once again, what is aminolysis? Ammonolysis is a process of addition of ammonia to an alkyl halide. Right? Every time what is happening? One hydrogen gets replaced. It goes on, it gets replaced till all the hydrogens are done. Let's come back. We have done a few reactions, preparations and chemical reactions. Now let us see one very important reaction of a amine. So what is that reaction? Reaction with HONO. What is HONO? Basically HONO is nothing but HNO2, nitrous acid. So what actually is the speciality of this nitrous acid? Let us see. Yes. So nitrous acid, now it has a particular important cation, that is your nitrosonium ion. That is very important. Now what does it have? This has nitrosonium ion. So because of this nitrosonium ion, we are going to get a different product in that particular reaction. Let's see. Suppose if they give me in the exam C6, okay, RNO2. Done. Now they've given me the nitrous acid. Done. What products do I get? I'm going to get 3 important products. What are the products? First one, I'm going to get an alcohol, I'm going to get nitrogen, I'm going to get water. How do I get this? We are going to see now. So this is your basic answer, but let us see. Now directly this will not get converted to your alcohol. We will see the reactions. First, RNO2. As I said, nitro groups are first converted to your amino groups. So for that, you're going to introduce metal acid. Then oxygen is lost and hydrogen is added. Yes. So what do I get? RNH2. Now, simple. Now this RNH2, when I'm introducing nitrous acid at less than 5 degree, I'm going to get R, an alcohol, plus nitrogen plus water. This is your concept. Now I have to see how am I getting alcohol. Let's see the mechanism. First important thing is your nitrosonium. Whenever you're adding nitrous acid, acidic medium, what happens? This nitrous acid, yes, let me write like this: OH, N double bond O. In the presence of acidic medium, sulfuric acid. How am I writing sulfuric acid? I'm going to write sulfuric acid as H and HSO4 minus. First important thing, let us see. 1, 2, 3, 4, 5, 6, 7, 8. Done. Now 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? First, when this combines in the acidic medium, there's a cleavage of the bond here and there's a cleavage of the bond here also. So what does this form? This is going to form or combine together to release water. I'm left out with this cation, left out with this anion. Now this is your nitrosonium cation. So that nitrosonium cation, it's like this: NO plus and HSO4 minus. Now observe, your nitrosonium cation is going to combine or react with your RNH2. So what do I get? I get, suppose if I take CH3 and H2, you can take R also. Okay, if it is confusing, write R. Now this in the presence of HNO2 at less than 5 degree. What did I say? What cation does it have? It has nitrosonium cation, N plus. Now we very well know nitrogen has a lone pair of electron, isn't it? Now this lone pair of electron is donated to this nitrosonium cation. So when it is donating, what do I get? I get R, N, because this has lost an electron. This becomes plus H. Yes. Now, okay. Plus here, H, and it's going to form a bond with N double bond O. Observe carefully. Now, what am I trying to show? I'm trying to show the formation of these products. That's it. This nitrosonium or this particular complex, I'm introducing, or you let us take out hydrogen from this, H minus H plus. From where? From here. Then what is going to happen? It's going to form a complex like this, R, N, your hydrogen, yes, double bond N and oxygen. Now this is your enol, that is your this is keto group. Oxygen is a keto group. This is going to show or form tautomers, or the concept is tautomerism. During tautomerism, one hydrogen from here shifts here. So what do I get? I get R, N, double bond, OH. Simple. To this particular this is your keto group, this is your enol group, tautomers. Now to this tautomers, this particular enol compound, I'm going to add H plus. This H plus is going and adding to this compound, R, N double bond N and OH2. We're gradually coming finally into the product. Now when I take this, just simple, there's a cleavage of the bond here, minus water. What am I left with? I'm left with this R, N, triple bond N plus. This is a cation, a zonium cation. Now further, when I heat it, nitrogen gas escapes out. Then I'm left with R plus. Now to this R plus, I'm going to introduce water. Simple. This is plus, so there's a cleavage, and minus goes in. This becomes alcohol. Now observe carefully. You have got an alcohol. You have got release of nitrogen gas. There is a removal of water. So this is your reaction. So please remember, very important reaction if they ask you, but the actual reaction is this. This is your actual reaction. Don't get confused. Don't directly write nitro to this, wrong. Nitro to amine, amine to this compound. So now, suppose instead of primary amine, if you are taking secondary amine, nothing, simple. Instead of H here, you get R group. Here H, R group. With that, it's going to vary. It's going to form an yellow color liquid, right? So this is your reaction. Very, very important reaction with HONO or nitrous acid. Let us come back and see the next section of your amines chapter. What did we learn in the previous video? You have seen how did I prepare primary amine from your nitro alkane, right? And further, I will also show you the different reactions which are involved with primary amine. We have studied about aminolysis, acylation, benzylation. Yes, we have also seen what is how is it treated with secondary amine. Everything, all the list of reactions you have studied. Now that's done with your primary amine. Now let us come to the second class of compound of this particular chapter. So what did I say in this chapter? You have nitro compounds. Done. You have amino compounds, that is amines. You also have cyano. Then you also have a subclass of compounds, that is BDC, benzene diazonium chloride. We are going to study that. Very important and easiest reaction of this chapter. So here I am going to show you the preparations and chemical properties together. First let us write the full form. BDC stands for benzene diazonium chloride. Okay, what is the formula for this? So benzene, aromatic ring, so I'll write AR. Di means 2, azonium means N2. N linked to one more nitrogen is azo group with N2 because it is di. Chloride, benzene diazonium chloride is this. That. The first important thing, let me start like the earlier one. First I have to prepare BDC, isn't it? What is the procedure? Now you are going to first take, suppose I'm just going to start with benzene. To this benzene, I will try to use a nitrating mixture. Same, it's the simplest basic thing which you have studied. This is going to supply me the electrophile NO2 plus. So this will form nitrobenzene. Simple. Now this nitrobenzene, what am I going to do? I am going to introduce reducing agents. So reducing agents, two types of reducing agents. One can be SN plus HCl or lithium aluminium hydride. Then these two are reducing agents. They are going to supply hydrogen to this. They are going to add this hydrogen, remove oxygen from here. Then what do I get? I am going to get a compound because hydrogen is added, oxygen is removed. I get from nitrobenzene, I am going to get aniline. Why? This is lost and hydrogen is added. This is called aniline. Now I still have not prepared BDC. From aniline, BDC can be prepared by two methods. One is either if you see in your paper NaNO2 plus HCl, one composition, or HNO2 also the problem. Both will convert aniline to BDC. Both the compound NaNO2 and this one will convert your aniline to your BDC. So what's going to form? Your HCl, isn't it? Now this whole compound is going to get converted to a new compound called N2Cl. From where did I get? Yes, reaction mechanism, I'll show you that also. This nitrogen so forms a bond here and Cl forms a bond here. Okay, so remember that is the reason we are using this in acidic medium also, this and this. So this N2 and Cl, N2Cl. So this, when you see these two, that means they want you to form BDC. So BDC, benzene diazonium chloride. Now to this BDC, just observe carefully. 1, 2, 3 conditions. This is one set to this BDC, 1 and 2. Remember, same BDC, if you are introducing or if you are finding this copper Cu2Cl2 in the presence of HCl, Cu2Br2 in the presence of HBr, CuCN in the presence of KCN. If you see this, observe what happens. First, as soon as you are heating BDC with such things, your here Cl minus, here Br minus, here Cl, nucleophile. That will replace first when I heat this with these. Nitrogen gas escapes out everywhere. Everywhere nitrogen gas escapes out. So this is going to form a compound called chlorobenzene. This escapes out. Here the nucleophile is bromine. So bromobenzene. Here cyano is a group which is going to attack cyanobenzene. Aparo. This reaction where you are converting BDC to chloro, bromo and cyanobenzene, these reactions are called Sandmeyer's reactions. So Sandmeyer's reactions. Done. Now the same BDC, if I am utilizing or trying to use only copper in the presence of HCl, or if I am using only copper in the presence of reducing agent, HBr. If I am getting the same thing, same products like this, Cl, and here the product which I obtain is, this is your Br plus nitrogen gas escapes out, isn't it? Escapes out plus nitrogen gas escapes out. Now, so this particular reaction with Cu by HCl, Cu by HBr is called Gattermann reaction. Gattermann reaction. So remember, important thing, whenever you have to prepare your BDC, try to take this. Why did I do this? Conversions. Convert benzene to BDC. Convert nitrobenzene to BDC. Convert aniline to BDC. So this is your sequence. So see, very simple. The reducing agent, aniline, I am getting BDC, and finally, so let us again meet with next set of reactions. So now we are going to see next set of reactions of BDC. Now what did we learn earlier? We said same thing. The process is the same, but that will vary from there. Benzene on nitration with the nitrating mixture, we are going to get nitrobenzene. We have seen that. Further, when I am using reducing agent, nitro is getting converted to amines. That is your aniline. Further, when I treat NaNO2 and HCl or HNO2 at 273 Kelvin, okay, 273 Kelvin, I am going to get BDC. So that's quite the standard reaction which I have written. Now, BDC, suppose if I am going to introduce two important things. What are they? I am going to take aniline to BDC. Okay, the structure not proper. Aniline, yes, now this is your hydrogen. Now I am going to take phenol. Just hydrogen, I just put it out. When BDC reacts with aniline, with amine in the para position, and when BDC reacts with phenol with OH in the para position, that such reactions are called coupling reactions. So what am I going to teach now? I am going to teach you coupling reactions. Just see what is important requirement. In coupling reaction, you're going to see that the amino group is in the para position and the hydrogen on this side. Here also OH on this para position, hydrogen on this side. Why am I saying that? Just see. Take this BDC and couple with this. When we are trying to couple, we are going to get dyes, different colored dyes, yellow and orange color dye. Let's see. I am taking BDC, Cl, that is your N2Cl, no? N2, okay. N2Cl, BDC plus. Club with hydrogen towards this side. That's important. That's why I took hydrogen on that side and NH2 on this side. HCl is out. Minus HCl. Both are, we are showing coupling. They're going to couple together and form one product. Now take this ring here. Structures, okay. Take this ring. Your nitrogen is still there. N double bond N. Why did I write double bond count? 1, 2, 3, 4, 5, 6, 7, 8. Lone pair. Done. Now this nitrogen is going to link with this. Now HCl has gone out, isn't it? So there is N2 here. That nitrogen is going to link this ring. This is NH2. So this is your first coupling reaction with amine. Okay. Now what is this compound? Para-amino azobenzene. Okay, let us write para-amino azobenzene. Okay, done. Let us write with phenol. How does this look, right? So let us erase this and then come back to phenol. Yes. So let us finish and write the product finally. Now I'm going to show you the coupling reaction of phenol. Same story. So again, coupling reaction. So for coupling reaction, I'm going to take BDC. BDC in such a way that your N2Cl is on your right hand side and your phenol you are going to write in such a way that your hydrogen is facing the chlorine and OH. Now during coupling, HCl is lost. When HCl is lost, what product do you get? You get a benzene ring here. One nitrogen double bond, this is very important, azo group linked with one more benzene, this one with your OH in the para position. What is this compound now? Para-hydroxy, P-hydroxy or para-hydroxy azobenzene. So this is your coupling reaction. Simple. Two products BDC is going to form. What is it going to form? With aniline, we have taken this as phenol. Okay, aniline, we are going to form para-amino azobenzene, and with phenol, you are going to form para-hydroxy azobenzene. Both are dyes, yellow and orange in color. So this is how you are going to show your azo coupling reactions. I'll meet you again with the next set of reactions. Right. Now let us come back and see the last set of reactions of your BDC. Till now we have learned different reactions, Sand-Mays reactions, Gattermann reaction. We've also seen what's going to happen, like how are you converting BDC into your acid group, amine group. Please watch all the videos in the sequence and note it in two or three pages depending on your handwriting. Now the main reason for me doing all sets together is more than that you'll not be asked in that particular question. So now last set of reactions. Now what happens now if I have to take this BDC, right? I've taken this BDC. Now I'm going to introduce or just show you three important conditions. What are they? Here I'm going to take BDC and introduce a reducing agent. So we are going to write reactions involving reducing agents. So what are the reducing agents which I am going to use in the exam? If you see ARN2Cl or ARN2Cl like this, and if they ask you or show you and this particular thing, what is this? Hypophosphorus acid. H3PO2 is hypophosphorus acid, and even water also depends on water. So when you're adding hypophosphorus acid, what is the role? H3PO2 is a reducing agent. So what does it do? It helps in reduction and itself gets oxidized, isn't it? That is what is the condition. Reducing agent, it helps in reduction but itself gets oxidized. Yes, this is your concept. Now H3PO2, when you add it, first important thing, whenever you're heating BDC, just remember nitrogen gas escapes out. That is the most important thing. This is done. After that, your H3PO2 gets oxidized to a higher oxidation state. From PO2 to it gets oxidized to H3PO3 phosphorus acid. Hypophosphorus acid, this is phosphorus acid. Let us write the name. Phosphorus acid. Oxidize or no? To higher O2 to O3. Done. Still not complete. You still have Cl. There is H and OH, isn't it? One H from here takes out this Cl and HCl comes out. Now what is left out? This is lost. Cl is lost from here, and this bond shifts into your benzene ring, forms your arene. That is your H, arene. So BDC to arene. So if you're not writing like this, you can write directly ARH. Done. So this is your role of your reducing agent. Let us take one more reducing agent. What is one more reducing agent? I am taking ethanol. Ethanol also is a reducing agent. So let us write CH3CH2OH is a reducing agent. H3PO2 is a reducing agent. Both will help in reduction and themselves get oxidized. So when I am taking this ethanol, same story. Whenever you're heating, first important thing, nitrogen gas escapes out. Done. After that, your hydrolysis. Okay, if I take this hydrolysis, that HCl also escapes out. Next important thing, this is your ethanol, isn't it? Alcohols in oxidation, what will happen? They'll get converted to aldehydes. How? Alcohols on oxidation, yes, loss of hydrogen. This hydrogen is lost on oxidation. What am I left with? I am left with CH3CHO. So we very well know alcohols on oxidation forms aldehydes. This on further oxidation gets acids. Okay, not a problem. So this ethanol gets converted to CHO. This is getting oxidized. See here. Done. After this is over. There is one more hydrogen existing that comes out as HCl, I said. This is lost. This is lost. This got converted. What are we left with? We are left with ARH. That's it. Arene. Simple. Yeah. So most important reactions, please practice it. Nothing. Reducing agent will get reduced to higher, oxidized to higher oxidation state. Aldehydes will get oxidized to alcohols will get oxidized to aldehydes. The leftover products are the same. N2 will escape. HCl is out. Now the same BDC, if I'm going to do or boil it, okay, what am I going to do? I'm going to take that temperature almost 283 Kelvin or something. If I take the temperature 283 Kelvin, when I have to add water to this, simple, you're boiling it, isn't it? When you're boiling it, first important thing is your nitrogen gas escapes out. Your chlorine is replaced by this OH and your HCl is out. And this OH goes and occupies its position, giving me phenol. So this is one of your conversions. What did they ask you? Simple BDC, water. You are hydrolyzing it when you are increasing the temperature to the 283 Kelvin. And when you are boiling it, immediately nitrogen gas escapes out. Done. Your Cl comes out with this HCl and your OH replaces that and gets phenol. This is your phenol, this is your arene, this also is your arene, your benzene ring rather. This is your aldehyde. Please remember, reactions with reducing agents, very, very important reaction. Of your BDC. Now, I hope you've seen in the previous videos also. First, this is your basic conversion everywhere. So, you hope if you've understood if you've gone with the sequence, this will be clear. Now, I'll erase this whole thing because I need BDC for converting it into different compounds. Now, we've already studied BDC. I try to prepare with Sandmeyer's reactions and Gattermann reaction. What did I prepare? With Sandmeyer's, I could prepare your chlorobenzene, right? With Sandmeyer's reaction, bromobenzene. With Sandmeyer's reaction, cyanobenzene. After that, I also try to prepare with Gattermann the same thing, chloro and bromo. But did we prepare iodobenzene and in halogens? Fluoro is not prepared. Chloro is prepared, bromo is prepared, iodo is not prepared. So we are left with two more halogens, that is preparation of iodo, benzene and fluorobenzene. We have not done this. Then let's see how can I prepare from BDC. Now one important thing, one more I'm going to show you. What happens when I treat CuCN in the presence of HCN? How can I use that? See. Now the same BDC which I've got from the earlier reaction into Cl. Suppose if I have in the exam, if they give you or say ask you to prepare iodobenzene, right? The reagent which you're going to use is potassium iodide. You can use Ki for this. Now this is one potassium iodide which has got our iodine as a nucleophile. This is going to attack this. So when you are heating BDC with KCl, also Ki, the first important thing, heating. When you are heating, your nitrogen gas escapes out, N2. Your Cl is replaced with iodine. Done. So you have got iodobenzene. What else is left out? You have KCl coming out. So this is how you're going to prepare iodobenzene. Done. Simple. After this, now let me prepare fluorobenzene. For preparing fluorobenzene, you will not use HF or something. No, wrong. You're going to here use a compound called HBF4. Very important. So this HBF4 is going to carry this fluorine to BDC. How does this do? Whenever you are adding HBF4 to this, first important thing, your HCl comes out. Because I have to replace with fluorine, isn't it? So minus HCl. Let us write the product first. Yes, you have N2BF4 minus. If you are further heating it. When you're further heating it, immediately the nitrogen gas which is there escapes out. Plus. Your BF4 is going to dissociate into two ions. One is F minus and next one is FBF3. This F minus still existing there. Fluorobenzene plus your boron trifluoride is out. 1, 2, 3. This is how you're going to prepare fluorobenzene. So this is your iodobenzene, this is your fluorobenzene. Simple, isn't it? I've prepared from BDC using both reagents. Now I'm done with this. Let us erase this. I'm done with the second one. Let us erase this. Now I have to use this copper CuCN, copper cyanide, tons of HCl. In the exam, basically when they give you CuCN and HCl, that means it is Sandmeyer's reaction to prepare. So in Sandmeyer's you prepared your cyanobenzene, done. So further cyanobenzene, if I have to further convert it, how is the question given? Convert BDC to RCOH, okay, or convert BDC to primary amine. Okay, this is a big confusion, right? How should I do this? Simple thing. Both the questions I can reason it or answer it like this. See, you're going to take BDC, introduce CuCN by KCN. Done. Now this is your nucleophile CN. As soon as you heat it with this, nitrogen gas escapes out. Chlorine comes out with copper chloride. This comes out as copper chloride. The leftover is CN, which is attacking. So I am going to get CN. Now what should I prepare? I have to prepare carboxylic acid of this. Simple. This is your cyanobenzene. Whenever cyanobenzene is treated with ethanol. Okay, what is ethanol basically? This ethanol is going to supply OH minus for us. Okay, so this particular ethanol, just place ethanol here. Done. That means you're trying to replace that or it's going to release that OH minus. But in the process, yeah, you can also do other than this, you can also take hydrolysis of cyano group. So what procedure I'm going to do? I'm going to use hydrolysis of cyano. When it is trying to hydrolyze this, observe. Now this is your oxygen, this is your hydrogen, isn't it? Now to this cyano group, these two are going to attack. How are they going to attack? Your oxygen is going to attack with the carbon. Your H2 are going to attack with this. How does this look? Oxygen first. Take this, convert cyano into CO and H2 with your NH2. This is called amide now, benzamide. Now still acid is not prepared. Further I am hydrolyzing it. Your NH2 comes out as NH3, ammonia, and the leftover OH goes and attacks this. Now you have got your acid C. Okay, carboxylic acid, no, benzoic acid, because we have taken benzene ring. So have I not prepared from BDC benzoic acid. What is the procedure? First, try to convert. Now, earlier I said first you will take in the earlier this one I said nitro is converted to amino. Okay, nitro R amino. After that, the series of steps you are getting RCN. Correct? This is what I said. Now same amino, if I treat it with the NaNO2 or HCl, which I said already, you're going to get BDC. Done? Simple. Now this BDC, I said further, if you treat with CuCN and KCN, what do you get? You get RCN. Here also RCN, here also RCN. Now this cyano group further, when you are treating with your ethanol or hydrolysis also, you can do hydrolysis also, you will finally get a compound called acid. My work is still not done. I asked you one more conversion. What was the conversion? Conversion of BDC to your amine. How should I do that? Simple. Take this BDC. Okay. Same thing. Yeah. Convert it into cyano. Done. So simple. I'll take the same thing here. So I'll repeat the reaction here so that it's not confusing. First, I'm going to take BDC into Cl. I'm going to introduce CuCN by HCN. Okay, HCN. Does write KCN or HCN? No problem. Yes. This will replace. You get minus N2 CuCl and you get cyano group. Now to this cyano group, I am going to introduce reducing agents. Reducing agents like Sn plus HCl, metal acid. You can use reducing agents, isn't it? Lithium aluminium hydride. Okay, I'll use lithium aluminium hydride. This is a reducing agent which is going to add hydrogens across the cyano group. One hydrogen. Okay, I said hydrogens. Let us see how many hydrogens. Here one hydrogen, here one hydrogen. But I want benzylamine, no? So what am I going to do? I'm going to take 2. That means I am adding hydrogen like this. So 2 hydrogens will add here. 2 hydrogens will add here. How does this look? This compound becomes CH2. The bond between these two breaks. NH2. This is called benzylamine. Right? So simple. Let us come back and see many reactions. First, if you want to prepare iodobenzene, this is the reagent. Fluorobenzene, this is the reagent. If you have to convert BDC to acid, or if you want to convert BDC to benzylamine, this is the step. This is the first step. This is the second step. Right, so let us come back and learn the next set of reactions of your amines chapter. So how did I start my chapter? Basically, I've given you an a type of conversion process so that it's clearly understood and you can have a mind mapping in your mind mapping so that it's easy for you to write in the exam. So we studied whenever you have to prepare amines, right? Your basic thing, you should first convert nitro group to amines. This is what I said, isn't it? From amines, you can convert it into cyano group. And I've also shown you the series of steps. And further, what did I do? I've taken this amine and I've shown you different types of reactions in the earlier video. Yes. So how did I teach you? I took the nitro and then by reduction process, I did amino. But today, we are going to learn, other than nitro, what are the different groups which will give amino. So let us write or learn the preparations of primary amines. Yes, by reduction process. So we are going to learn under a process called reduction. Yes. So whenever I speak about reduction, I have to basically speak in terms of reducing agents. So what are the different reducing agents I can use? I can use metal in the presence of acid. I can use Fe in the presence of acid. So all these are reducing agents. I can use lithium aluminium hydride as a reducing agent. I can use Sodium metal in the presence of ethanol. This is also a reducing agent. So yeah, I can use any of these to convert or to reduce that particular given compound. Yes, with that data, the reducing agents, I'll start my topic. So I have to prepare primary amines by reduction of what am I going to reduce? I'm going to reduce three important products. What are they? First, I'm going to reduce reduction of nitro compounds. Yes, done. Now we are going to take a reduction of nitriles. Okay, nitriles. Let us underline. Next, we are going to learn a reduction of amides. Okay, this is how it was given in your textbook also. Yesterday, we studied this category and I further went teaching you, we have prepared amines, then amines, and then we have gone to preparation of BDC also. I've shown the different types of reactions of BDC also. So, let us come back and learn further more preparations of amines. So, reduction of nitro compounds. So, I said reducing agents are those. Let's let us write the general formula. RNO2 plus. Okay, I am using a reducing agent like SN by HCl or Fe by HCl. So this is a reducing agent. In the exam, if you find this particular reagent, it means you have to add hydrogen. So now I have to remove this oxygen and add hydrogen to this, isn't it? So let me add 6 hydrogens to this. I'll tell you why. When I add 6 hydrogens, 2 will go here. So what do you get? R NH2, already 2 have gone, we still have 4. So 4 hydrogen come out as 2 water molecules with this oxygen. So didn't I prepare primary amine? So let us write with a general example. Suppose if I take CH3NO2, okay, nitromethane. Yes, so let us write nitromethane. Again, I am going to add 6 hydrogens. Simple. We are going to take reducing agent SN by HCl or Fe by HCl. Reducing agent. Simple. You have to remember the reducing agents and go to exam. Now here this oxygen is released out and among 6, 4 or 2 will add here. Please see 2 hydrogens. So what do I get? I am going to get CH3, NH2, 1 and the leftover out of 6, 2 have gone. 4 are left. 4 will come out with this as 2 water molecules. Always remember. So this is nitromethane. This is, if I have to name, methylamine. Okay, right, methylamine. Okay, otherwise if you want to write okay, nitromethane, correct, methylamine, nitromethane. Let us write for aromatic. If I have to take nitrobenzene, right, this is nitrobenzene, I'm going to again add 6 hydrogens to this. And the same story, use reducing agent HCl. Again, or you can also use reducing agents like iron in the presence of HCl. What do I get? 2 hydrogens will go here. Simple. What do I get? I get aniline, NH2 and the leftover comes out as 2 water molecules. This is how you're going to prepare using reducing agents. So till now I did this yesterday and I further proceeded. Now I'm stopping it here. Done. Let us come back to nitriles. What are nitriles? Nitriles are nothing but cyano group. Done. Let me write general formula. R, C, triple bond N. Right, so cyano group are called nitriles. Now I have to reduce, all the reduction isn't it? Now I'm going to use a reducing agent. Let us pick up lithium aluminum hydride or sodium in the presence of ethanol. Anything simple. Now what do you require? First important thing, whenever you have triple bond, this triple bond, this bond first breaks. Correct? Yes, when you're breaking this bond, simple, yeah, 2 hydrogens here and 2 hydrogens will add here. Then only you will get your primary alkane or primary amine. Yes, we are preparing primary amine. So how many do I need? I here need only 4 hydrogens. Why do I need 4 hydrogens? Just observe. 2 will attack here by breaking the double bond and 2 will attack here by breaking the double bond. What do I get then? I get R, CH2, NH2, simple. No water molecule here because there's nothing, no oxygen to form. Let us write an example. When I have to write an example, CH3, C triple bond N. What am I doing? I'm going to take 4 hydrogens. Again, I'm going to introduce reducing agent here. I don't have place, that's why I'm writing Ra. So what did I say? 2 hydrogens will add here, 2 hydrogens will add here. What product do I get? I get CH3 CH2NH2. Let us name this compound. So now how should I name? We have tried different combinations. I know alkyl. Simple. Start from this, right? This is methyl cyanide. Alkyl cyanide. So this is alkyl cyanide. This is methyl cyanide. Simple. Write that. So let us name this. I have a place. I am writing methyl cyanide. Done. Now what happened to the product? Here 2 carbons are there. So this becomes ethyl amine. Primary amine. Done. Yes. Now let us come back and start with an aromatic ring. Now I have an aromatic compound with C triple bond N. What is this compound? There is no other group attached to cyano. Cyano is directly attached to benzene. So this is phenyl cyanide. To this phenyl cyanide, I am going to introduce or pick up these 4 hydrogens and add a reducing agent, for example, like sodium in the presence of ethanol. So this reducing agent is going to add 2 hydrogens here and add 2 hydrogens here. Then what do I get? I get a compound like benzene ring. Careful. Now C has become CH2. Then this is NH. Now what is the difference? This is phenyl group with cyano compound. Yes, I just added hydrogen. Let us take that out so that's not confusing for you all. Now to the phenyl cyanide. Now you have one more group CH2, then only amine. So this is called benzylamine. If you have a group attached to benzene ring adjacent to your functional group, then we call it as benzyl. So name it as benzylamine. Done. Yes. So what did we prepare? Here we took nitro, we prepared methylamine. Here I took nitro, again I prepared aniline. Here I took cyano, I reduced it, I prepared ethylamine. 1 carbon higher than this. Means like 1 carbon higher means that, sorry, the carbon has got the hydrogen, 1 hydrogen higher. Done. Here 2 hydrogens, here 2 hydrogens. Again you have cyano, I added 4 hydrogens, 2 will add here, 2 will add here. Done. Now let us see amides. So what are amides? RCONH2 are called amides. So again I am going to add reducing agents like sodium in the presence of ethanol, C2H5OH. So what happens? Important thing, you are going to add hydrogen, okay, 2 hydrogens. Why? In your amide, this is a site where your hydrogen is going to add. So 1 oxygen is out and 2 hydrogens are in. What do I get? RCH2NH2. Just see, simple isn't it? Fine. Suppose if you take 4 hydrogens, let us assume if I take 4 hydrogens, what will happen? This 4 hydrogens, 2 will go and add here and the leftover 2 will come out as 2H2O. Okay, let's see. Oxygen is 2. Done. Now here oxygen is only 1. Hydrogen has become 4. 4 plus 4, 5, 6, now 7, 8. Isn't it? So what should I do? Simple logic. Try to pick up 2 hydrogens and try to make this product. Yes, so let us see. CH3CONH2. I can add 2 hydrogens to just prepare this primary amine in the presence of sodium and ethanol. Convert this CH3CH2NH2 because only 2 hydrogens I added. Now what is this compound? This is obtained from acetic acid, isn't it? So acetamide. This is acetamide. Now what is this? Ethylamine. Acetamide, ethylamine. Done. Let us take with an aromatic amide. So I am going to take benzamide now. COCH3. I am going to introduce 2 hydrogens only. Then what do I get? In the presence of sodium and ethanol, I am going to get benzene ring with CH2NH2. Yes. Yeah, this is your compound. Simple. Don't get confused. Every time remember, reducing agent will go and act at that oxygen position only. Oxygen here. Here triple bond, here oxygen. Once you find these reducing agents, don't just try to change the sequence or the number of carbon atoms. Directly go and take out that oxygen and add hydrogen. You will get the product and start naming or labeling the product. So let us come back and do the next reaction, that is your Hofmann's bromamide reaction. Basically, when in the exam, suppose this is given to you, you don't remember anything, one line at least please try to learn and go. I'm talking about students who, like, if you tend to forget, one important thing, what Hofmann's bromamide synthesis, this is used to prepare just one line. Remember this line, please, you will get 1 mark. Used to prepare aliphatic and aromatic, yes, primary amines from, right? So from where, if you can at least remember till here, okay, from where, that is important, that is also important, rather, from amides. Yes, so at least this word, please remember. And okay, now let us go into the basic thing. Now, whenever you're preparing or whenever you have to prepare any primary amines or primary amines, that is aliphatic primary amine and aromatic primary amine, simple. We try to use Hofmann's bromamide reaction. What is that? As the name suggests, bromamide, simple. Now, what are you going to do? First, take an acetamide. Take one acetamide. To this acetamide, you're going to introduce bromine gas, G. In this bromine gas, you're going to introduce, or this is going to we are going to carry this reaction in the presence of a base, strong base. Then when you're carrying this whole thing under these conditions, simple, you just start from here. You're going to pick up 4 moles of KOH so that it's easy. Now, then you get a product called alkyl amine plus your KBr plus K2CO3 plus water. So when you balance this, this also 2, this also 2. So this is the basic reaction, right? In the exam, you have to show this reaction with examples. Now I said we are going to prepare both aliphatic and aromatic amine. Let us take first general example. First, acetamide. What is acetamide? Now this is your acetic acid, isn't it? This is your acetic acid. Now what am I going to do? I'm going to take out this OH and I'm going to add NH2. Now this becomes acetamide, amide group, acetamide. To this acetamide, I'm going to add bromine gas. Along with that, we are going to add a strong base. How many did I take? 4 moles. Now observe. First important thing, this particular CO, isn't it? Now this CO, observe carefully, this whole CO will come out with this potassium as carbonate. Remember, why? In acetamide or Hofmann's bromamide, you get an alkyl amine with 1 carbon less. That is the main concept. Okay, acetamide to alkyl amine with 1 carbon less. This is very important. Don't blindly write carbon less. Don't blindly write when you see amide. Don't reduce it and please don't do it. 1 carbon less amine should be prepared. So now how many carbons you have? 2. Now take out 1. This will become CH3NH2. This is 1 carbon less, isn't it? This is 2 carbons here. 2 carbons here. This is 1 carbon here. What is this compound? This is primary amine, that is methylamine. Now, okay, methylamine. Now done. Now let us see. This part is over. Let us come back. Now you have 4 potassiums, right? 1, 2, 3, 4. Okay, now OH is like this. Simple. Reaction is very simple. How should I write? First important thing, your potassium with bromine comes out as KBr. Okay, now how many did I take? 4, isn't it? Now in this KBr, let us pick up these 2 or out. So 2 KBr. Done. Still I have 2 potassiums. Yes. Now you also have CO. Done. Like K2. C O So this is out, done. These two are out with Br, done. These two are out here, K2. Now CO is also coming out, but observe carefully, CO3, potassium carbonate. Now here potassium carbonate, now observe 3 oxygens have gone. So 1 gone, 2 gone, and this also has gone. Now what are we left with? I am left with your hydrogen 1, 2, 3, 4. So 2 2s are 4. So 4 H2, okay, 2 to the 4. How many oxygens? 2 oxygens, water. So 2 hydrogens, 1 oxygen, 2 oxygens. So 2 to the 4 hydrogens, 1, 2, 3, 4, and 2 oxygens. So 2 oxygens. Simple, isn't it? So I've got, this is your Hoffman's bromamide reaction. Now suppose if I have to prepare, this is your aliphatic amine, isn't it? Yeah, now let us prepare aromatic amine. So for that, what am I going to do? I'm going to take benzamide. This is CONH2. This is benzamide. To this benzamide, I am going to add bromine gas again. You add 4 KOH, same thing. Here you are going to get 1 carbon less, careful. So you are going to prepare benzene ring. This CO comes out as potassium carbonate, as I explained earlier. Products are the same. 2 kBr. I've explained earlier, isn't it? 2H2O. And the leftover, this is gone. I'm going to get aliphatic amine. So this is aliphatic amine or aniline. Aniline. Simple. So most important thing is picking up bromine gas, because bromamide reaction, and important thing, you are taking 4 KOH, 4 moles of KOH. Otherwise, you will end up writing some product which has the same number of carbon atoms. Wrong. The product will have with 1 carbon less. Here CO, benzene ring. Here no CO. Here CO and H2. Here no CO. So this is your Hoffman's bromamide reaction. So we've already learned how to prepare amines, right? What did we learn? We've learned reduction of nitro compounds, reduction of cyano compounds, and reduction of amides also. Then gradually we went into a topic called Hoffman's bromamide reaction. What did I say? By Hoffman's, I can prepare the primary amine, both aliphatic and aromatic. Now let us come back to one more name reaction, that is Gabriel thalamide reaction. So important. So what actually is this reaction? This particular reaction is going to use a compound called thalamide. That is why it is called Gabriel thalamide. Don't get confused in the exam. Thalamide is a very simple compound, just how to write. So first try, as soon as you see this word, draw the structure of thalamide. Your benzene ring. Okay. So aromatic, done. And you have CO. Okay. Done. Basically, if I say amide, it is CO and H2. Now, imide means both the CO groups, you have only one NH linked. That's why this is called imide. One nitrogen, so imide. So this compound is called thalamide. So thalamide, what are you going to use? You're going to use the most important thing, alcoholic KOH. This is very important. What is this? What is KOH doing here? KOH is going to supply this OH minus. That's why we call it as nucleophilic substitution reaction here. This KOH, in the presence of an alcohol, is going to supply that OH which will replace. Now, actually, if I have to see the, when I go to the background part of this, now your thalamide, you can remember this before you go for the exam, first gets converted to potassium thalamide. This potassium thalamide gets converted to N-alkyl thalamide. This N-alkyl thalamide further gets converted to phthalic acid, and we are getting our primary amine out. Okay, right, simple. This, if you remember this phthalic, this whole step, everything is easy. So thalamide, remember, because if you see the name reaction, simple. Now let us go with the step. Now this KOH, I said, is going to supply OH in the nucleophile. Now first important thing, there's a cleavage of the bond here. This potassium, okay, there is a cleavage of the bond here also. This potassium goes, because I said this is going to supply, this comes out as water, and potassium goes and attacks this nitrogen. What product do I get? I get one benzene ring, CO here, again CO, join this with NK. Now what is this compound? Potassium thalamide. Okay, let us write. I've written thalamide here. So this is potassium thalamide because NH, thalamide, done. Now to this potassium thalamide, you are going to introduce an alkyl group. Why am I introducing alkyl group? Because alkyl halide. Why? Because this alkyl halide will come out as amine here. Yes, simple. Let's see this. So alkyl, this RX, done. Now what's going to happen here? This K comes out with X and alkyl groups goes and occupies this position. Let us come down to this. CO, what did I say? N-alkyl thalamide. See here. N-alkyl, okay? N-alkyl thalamide. Done. Now still we have not completed. From thalamide, suppose let us write N-alkyl thalamide. Thalamide. Don't write A by mistake. It will go wrong. Now this N-alkyl thalamide, further if you hydrolyze this, done. When you hydrolyze this reaction, what do you get? If I'm taking 2 moles of this like this, there is a cleavage of the bond here. There is a cleavage of the bond here and here. Your RN, these two which are formed from alkyl group, will come out with these two hydrogens forming RNH2. Have we not prepared primary amine? Yes, we have prepared primary amine. Now what else is left? Your OH and OH goes and adds because the bond broke here and here. Done. That has come out. So this becomes minus and minus, isn't it? So this one goes and joins to this CO group, and what do you get? You get a compound called phthalic acid. See here, COOH and COH. This goes and attacks here. This goes and attacks here. This is called phthalic acid. P is silent, phthalic acid. So just see. Let us compare. Thalamide, first compound, yes. Alcoholic KOH, yes. Potassium thalamide, done. N-alkyl thalamide, done. Further hydrolysis, phthalic acid and primary amine. Primary amide, no. This is primary amine prepared. So how should I write this name? Statement, word statement. Gabriel thalamide synthesis is a synthesis which is a reaction which is used to synthesize primary amines. When thalamides are treated with alcoholic KOH, which is going to supply OH minus ion, hence nucleophilic substitution reaction, and further it's going to form potassium thalamide, which further in the presence of an alkyl group. Okay, so let us write KX here. In the presence of an alkyl halide, you're going to get N-alkyl thalamide, with on further hydrolysis forms phthalic acid and the required primary amine is prepared. So this is how you're going to write the word statement in the exam. If you don't remember, at least try to learn this and go. Reaction if it is confusing, try to learn this. You'll be given at least 30% of the mark. So we've learned Gabriel thalamide synthesis. Let us see one question which is commonly asked under this Gabriel thalamide. So we said Gabriel thalamide is used to prepare primary amines. That is your aliphatic amines. Now the question asked is, why cannot aromatic primary amines be prepared by Gabriel thalamide? So basically I said the KOH which is there, alcoholic KOH, is going to supply the nucleophile, that is OH, and they undergo nucleophilic substitution reaction. But here important thing, aromatic amines, very well know, do not undergo nucleophilic substitution reactions. Yes, with what? When the thalamide is forming an ion with that OH, isn't it? We just go through the whole reaction, you will understand. So important thing, aromatic amines, they don't undergo NSR with the anion what is formed with thalamide. So with the MSR with the anion formed by thalamide. That is the reason they do not They can't, because they don't form. They show Gabriel thalomite synthesis. If you don't remember this, just they do not undergo NSR. That's it, simple. Now let us come back and to solve such questions. Now, what do they give us? We have already learned. If you have seen the earlier videos, it will be easy for you. But such questions are quite common in amine chapter. Let's see. What do they give me? They've given me alkyl halide. They've given me NaCN. Simple. Now this is here nucleophile. Here this is Na plus and Cn minus. So the nucleophile, this comes and substitutes this chlorine. Then what do I get? I get a compound C2H5Cn, ethyl cyanide. Done. Now what did they give me? This ethyl cyanide on reduction itself. So reducing agent, we said Sn in the presence of HCl, or Fe in the presence of HCl, or nickel, yes, also metal atom. Again, they've given me hydrogen. They've given me all the clues. As soon as such question is given to me, I can see this metal atom, I can see hydrogen, I have to add to this. Where will I add? Basically, your cyano is this component, isn't it? Yes. Hydrogen, 2 hydrogens add here and 2 hydrogens add here. Simple. So this becomes C2H by CH2NH2. Simple. Done. This is your compound. Now let us go with the second one. Now they've given me aniline. Okay, whenever I have observed NaNO2HCl, simple logic, sodium nitrate plus HCl combination, that reaction will always produce BDC. Remember, aniline to BDC. Simple. We have done this reaction in the earlier video. So aniline, which when treated with NaNO2HCl, it's going to form a product called BDC, C6H5N2Cl. Okay, done. BDC I got. Now what did they say? This BDC, I've shown one line, isn't it? Yeah, in that video, that sequence, same thing they're following. This BDC again undergoes one more reaction with amine. So isn't it coupling reaction? Observe carefully. We did this earlier. What? You have benzene ring like this. You have N. Okay. Plus hydrogen. And I'll write like this: benzene ring with amine in the para position and hydrogen here. I hope you would have seen the coupling reaction video, then it is clear. Otherwise everything become Greek and Latin for you all. Please watch that coupling reaction, then it's easy. Now remove HCl, and what product you get? You get benzene ring with N double bond N and your amine group on one side. What is this compound? This is called para-amino-azobenzene. So para-amino-azobenzene is a product asked. This is how we are going to solve the questions. Only thing, you will be able to do such questions when you have a grip on the chapter. When will you have grip on the chapter? Please watch the videos in the sequence. You will easily understand how to solve such questions. Right, let's see one more set of questions. Little bit, we are trying to club the topics which I studied till now. Yes, so now they've given me the same story. As soon as this conversion is given, see what is present on the arrow. This is very, very important. Now what is this KCN doing? What will it do? It's going to supply CN. Okay, take your pencil and write. It's going to supply this nucleophile. Okay, CN, nucleophile. Okay, then after that, again take your pencil. What is this agent? It is a reducing agent. Reducing agent, it has to add hydrogen, right, like this. Now HNO2. Okay, I did a video on reaction with HONO. Remember that HONO will give you or form alcohols. Remember, what's that video I've also shown you? It's going to form alcohol, it's going to release nitrogen gas, it is going to release water also. Learn that reaction, then only come back to this. So this is going to, HONO is going to have, or it possesses an anion called nitrosonium anion. Remember that specular reaction with HONO. So this HONO, what will it give me every time you see? It should register that you will get an alcoholic product. Done. Let us come back. Whenever you see ammonia, what did I say? We prepared one compound called amide. I said from acetic acid, when you add ammonia, this will go and form amides. Ammonia will form amides. Remember. Next, bromine in KOH. Where did we do this? We did just 10 minutes before. Hoffman bromamide reaction, isn't it? This KBr and KOH. So these reagents are Hoffman bromamide reaction reagents. So what will bromamide reagents? What will Hoffman bromamide reagents prepare? They're going to prepare amines. Which amines? Primary amines. Okay, let us write. And now CHCl3 and AOH. What is this reagent? This reagent basically is used in carbylamine reaction. Okay, I'm again stressing, please watch the earlier videos, then only do this, otherwise you will not be able to understand this. I've already done how to do that reaction. This is clubbing of all the videos together under one video. So what's that? So CHCl3 and NaOH is carbylamine reaction. So what will carbylamine reaction give me? It will always form isocyanides. So with this data I'll start writing. Now CH3Br is going to supply CN. So take this alkyl bromide, and with KCN, yes, you get CH3CN and minus KBr. This is your A. Done. To this compound, I am going to use reducing agents which will supply hydrogen. How many hydrogens? 2 will add here, 2 will add here. Correct? So CH3, CH2, NH2. This is your compound B. Further, I am going to take with HONO. This is HONO2 or HONO. I said what are they going to prepare? They are going to prepare alcohols always. So take this compound directly, write alcohol. This is compound C. Simple. Let us come back. Now acetic acid with ammonia. Now how is this reaction? Basically I'll write the reaction first. This is ammonia, isn't it? NH3. Let me write as H, H2 and H. And take out this water molecule from here. When you take out water molecule, what are you left with? This NH2 will come and add here. So let us remove this water, and when this goes and adds here, what compound do I get? NH2. So write that compound first. Acetic acid in the presence of ammonia and heated. What is released out? Water. OH is replaced by NH2. So just now I showed you CONH2. Acetamide. Acetamide. I got amide. Then Hoffman's bromamide reaction. Hoffman's bromamide reaction will prepare me primary amine, one hydrogen, one carbon less. Remember that. So primary amine, this carbon, no, this is going to come out as potassium carbonate. I told you in the earlier reaction. So what do you do? Just take like this. Just remember, this will get eliminated as K2CO3, nothing to write. You will not write anything else. You will just note this. Byproducts, okay, you can write byproducts, but concentration will go more on the main products. So you get CH3NH2. So I got primary amine. After this, what are we going to do? We are going to take CH, chloroform plus KOH. So chloroform, NaOH is given to me. Okay, done. Right. Chloroform and NaOH, carbylamine reaction. This is going to get converted to CH3 isocyanide. Methyl isocyanide. This is how you're going to do your question. Most important, you can just byproducts you have to write. It's not a problem even if you forget, but main product should be written and labeled. So please note the question. Careful. First you should know what is present on the arrow. What is the role? So write that separately and you can finish off this answer. Now let us come back and do next set of such reactions. Earlier they've given you to find out A, B, C, D like that, but here they may give you directly also. So as soon as such question is given to you, where should your concentration go? Your concentration should directly be focused on this particular point. This is your main thing which is there in the arrow. That particular thing will give you the whole information, but the basic data should be there or prepared before you go for your exam. Again, we have HONO. I said HONO, that reaction is very important. Whenever you have nitrous acid in the reaction, you have to always prepare alcohol. Apart from that, nitrogen gas and water. Watch the reaction video. I've already done that. So HONO is given blindly. They've asked me to name the main products. So side byproducts, I not required to write. So main, take this amine. Nothing to do, don't write any mechanisms, simple, that's it. This is, watch the video please, done. Now again they've given me, what is this reagent? This is called Hinsberg reagent. Hinsberg's reagent, this also, one video was also done on this. Which type of reaction was that? Whenever you see Hinsberg, you should remember it always undergoes coupling reaction. Then suppose in the exam, if you're not able to write the product, at least if you write this coupling reaction, half mark will be given to you. Please remember, Hinsberg reagent is C6H5SO2Cl, sulfonyl chloride, benzene sulfonyl chloride. So let us come back. So what product did I say? Let us write the reaction which is going to occur with Hinsberg reagent, S double bond O Cl. Now add this. How will you add? Your Cl and H, try to make it adjacent so that's easy for you to take out. Okay, and now the NH. Okay, I don't extra. Yes, NH. Remove this HCl. Remove this minus HCl. What do I get? I'm going to get benzene ring with SO2 and NH. Okay, there is C2H5 also, isn't it? So I should not forget that C2H5. This is your product. So simple, isn't it? So just whenever you see such, if you see amine with, okay, if you see aniline here or phenol here, you have to do coupling reaction. Let us erase everything and write the main product here. That's it. Simple, isn't it? Now let us come back. Now what is on the arrow? Bromine with NaOH, bromine with KOH, Hoffman's bromamide reaction. Same story again. Hoffman's bromamide reaction will always prepare, as I said, it's going to prepare primary amines. But which primary amine? With one carbon less. You should not write this carbon, right? Because that comes out as sodium carbonate here. So take this whole amine, write CH3, forget about the CO and NH2. Methylamine. Now see, there's one carbon less, isn't it? Compared to this. This was 2 carbon. This is 1 carbon. So that is your Hoffman's bromamide reaction. So this is how you're going to solve the questions. So let us come back and do this identification type question. So it's basically one way is to find out A, B, C, D like that. Otherwise they may give you the reagent and one-step reaction that way. Or they may club in the form of a paragraph and give you and ask you to name or identify the compound. Let's see. So they said an aromatic compound A on treatment with aqueous ammonia. Okay, let us write the basic thing. A itself was treated with aqueous ammonia. Now what did it give? Okay, A on treatment followed by heating forms compound B. Okay, on heating forms compound B. Then which on heating with bromine and KOH. So Br2 and KOH forms compound C. And they've given me the formula for compound C because at least if one clue is given to me, it's easy for me to do the whole thing. What is the C6H7N? Okay, so C6H7N they said. Let us write. Now your benzene ring formula is C6H6. Done. But when it shares or it forms a bond with nitrogen, this becomes C6H5. Let us write that. So this is C6H5. Done. Now I still have 1 nitrogen and I still have 2 hydrogens, isn't it? Out of 7, 5 I have written, I have till 2. Okay. That means it is aniline. Done. I have written that. So let us take that and write as compound C. This is aniline. With the formula given to me. Let's start. So they said compound A with aqueous ammonia will give me compound B. Now remember this Br, bromine and KOH, what is this? See, where is this used? This is used in Hofmann's bromamide reaction. Okay, let us write Hofmann's bromamide reaction. I said it can be used to prepare aliphatic and aromatic amines. Now in Hofmann's bromamide reaction, what did we take? We have taken a compound called amides. Yes, amides we then later converted into amines. Yes, so this should be compulsory amide. Why? This will convert amides only to amines. Okay, if this is amide, how will I get amide? I can get amide by adding ammonia to acetic acid. We've learned this also. How? If this compound is acetic acid, how did I come to acetic acid conclusion? Because amide only how bromamide reaction is going to occur. So compulsory this should be amide. So come back, take acetic acid and add, okay, aqueous ammonia they said. In aqueous ammonia, if I take, suppose NH3 isn't it? Let me take H and NH2. This hydrogen comes out with this as H2O. Done. And what am I going to add? I'm going to add NH to this. So I get a compound CO and H2. Done. Amide. This is acetic acid. No, sorry, this is benzoic acid. Benzoic acid in the presence of ammonia is forming benzamide. Benzamide with Hofmann bromamide degree or bromamide reaction, I said this one carbon less. This is lost with K2 potassium carbonate. Watch that Hofmann bromamide reaction, you'll understand why am I trying to say this. And one carbon less, you get C6H7N, that is aniline. Apart from that, I said it's going to be potassium carbonate, potassium bromide. We've already studied that. So this is aniline. So this is what they want you to write. They asked me to find A. So what did I get? A is benzoic acid. B is benzamide. C is aniline. It's not clear. Okay. That's it. This is how you're going to solve the reaction. But important thing, one clue will be given to you from where you can derive. An important thing, you will be given the reagents. You should be clear with the reagents. Yes, chloroform means carbylamine. NaNO2HCl, that thing where you're converting into chloro-bromo, benzene, Sandmeyer's. Bromine and KOH, Hofmann's bromamide. Yes, for Gabriel phthalimide, you'll use alcoholic KOH with phthalimide. So, this is your reaction. Right, let us come back. We've already completed the preparations of amines. We've studied the chemical properties of amines, and also I've discussed about BDC, that is your benzene diazonium chloride. I also showed you how to preparations of BDC and as well as chemical properties of BDC. So we are left with now reasoning questions of the chapter. Now I'm starting with your physical properties of amines, and then gradually I'll go into your chemical properties, that is your reasoning questions. Let's come back. So the question asked is based on solubility, physical property. Why are lower amines or lower members of alkyl amines soluble in water compared to aryl amines? Okay, so we have one alkyl amine, one aryl amine. So let's write. So whenever a concept of solubility is given to you, the key word which you should use is hydrogen bonding, correct? So whenever you see this word, try to use the word, as I said, hydrogen bonding. So just start your answer like this. Alkyl amines exhibit hydrogen bonding, and take a pencil or pen and put it in inverted commas. This is important. Due to hydrogen bonding, due to which they are soluble in water. Right. So when I have to come back and write the same, aryl amines. So aryl amines. I hope you know what are aryl amines. Alkyl amines are RNH2 and aryl amines are benzene ring with NH2. That is your aniline. Right. So now aryl amines, the same thing. Do not exhibit hydrogen bonding due to large hydrophobic aryl group or the benzene ring. Hydrophobic means water hating benzene, okay, aryl ring. So this is the concept. Right. Let us show the hydrogen bonding. So what did we say? Hydrogen bonding basically between oxygen and hydrogen. Yes. Here what do we have? We have nitrogen in the amine ring. Simple. Take your hydrogen, right? Just okay. Then this is water molecule. Now this is going to form a hydrogen bonding between hydrogen and your nitrogen of the next group. That is your amines. Suppose if I take this as R, H and H. Now this is your hydrogen bonding between electronegative atom and your hydrogen. So because of this is your hydrogen, because of this they are soluble in water. If I have to write, now here this is your hydrogen. Now try to link this hydrogen. Now this is your hydrogen, isn't it? Try to link it with the next element. Now let us write again this. Simple. Now what should you write? You have to write for water. Now this is water. This is your amine. Again you should have water. So how should you write? Fine. This is your hydrogen bond. Because of this they are soluble in water. That's it. Right. Now let us see one more type of question, right? This is account for the following. Earlier we have seen complete the following. Before that we have seen increasing and decreasing order of basicity or solubility or this one pKb value. And now we are coming back to one more concept where account for the following is a quite common word in your board paper. Let's see how are they going to question you. Now they've asked us pKb for aniline is more than that of methylamine. Okay, this question was already done, but if they're asking you for 1 mark, how should you write? Right, let us write this answer. We very well know pKb, whenever pKb concept is given to you, one important clue which should strike your mind is strong bases will have low pKb. This should always should have this in your mind. If you don't, if your pKb value is not given to you, how will you analyze that? Yes, more alkyl groups, R is alkyl groups, they are highly basic. You should remember this. Then only I can explain you what is that concept. Now pKb for aniline is more basic, it seems. Okay. Other way around. Weak bases have high pKb. Done. Let's come back and do. In aniline, when I have to see or compare aniline and methylamine, this is your methylamine. This is your aniline. Now, I've shown one video where I explained the resonance structures of aniline. I explain you because of the resonance, the aniline is a weak base. Watch that video where all the resonating structures are drawn. I'm not drawing it here. Please watch that video. Now here, this is a strong base. Why? Based on this concept. Because of electron releasing methyl group. This is releasing electrons, isn't it? When it's trying to release electrons, your electron cloud becomes more and more. When electron cloud becomes more and more, it easily donates electrons. Yes, hence basic. So electron releasing group increases electron density. So this is your first concept. Second concept is this. Third concept, when it is donating, yeah. Okay, we have done almost, I think, no? Right, strong base, yes. Why strong base? Because electron density. When electron releasing group, it increases electron density, yes. Hence, pKb will be, I said, for strong bases, pKb will be low. Simple. Let's come back. Here, in case of aniline, what are you observing compared to this? Most important thing, delocalization of electrons due to resonance. Now your lone pair of electrons are given to this, the shifting of pi bonds. Yes, first important thing, aniline is a weak base. Why are you saying it is a weak base? Because of electron withdrawing benzene ring And what happens here in benzene ring? Concept of resonance. That is your delocalization of electrons. Because of this delocalization of electrons, are electrons available for nitrogen to give? No, isn't it? Electrons are not available for donation. When it is not available for donation, automatically the weak basis. When it is weak, what will happen to the pKb? pKb is higher. So simple thing. What should you do? Start comparing. Then only you can easily write an answer. I've compared between strong and weak. Point number 1. I've compared between electron releasing and electron withdrawing. Yes. And because of this, electron density increases. Yes. Because of this, electron density decreases. Done. Then I've come back to pKb. I said low for strong bases, pKb high for strong bases, so for weak bases. This is your answer. Let's come back and answer the B part. Now they said aniline does not undergo Friedel-Crafts reaction. We have done nitration reaction of aniline, sulfonation, halogenation, but we have not done Friedel-Crafts alkylation, acylation. What is the reason, they asked. Now first, as soon as such question is given, copy that question here. Aniline does not undergo reaction because, and start. Now this is your aniline. In Friedel-Crafts reaction, what is the acid, Lewis acid, it's going to combine with anhydrous AlCl3. Yes. Now, what is the comparison? Now, aniline is a Lewis base. This is a Lewis acid. Correct? Now, and this is your Friedel-Crafts reaction. Now, we very well know what is a Lewis base. Lewis base tries to donate an electron pair to Lewis acid. Yes, it donates electron pair, which nitrogen has. So, when it is donating an electron pair, it's going to form a salt. What type of salt does it form? It's going to form a salt, just see, NH, right? So, see here, NH2 plus AlCl3 minus. Together, it's going to form a salt. Now, what charge are you observing on amine? You are observing a positive charge. Now, this is plus. So, now tell me, already there is a plus here. Will it allow electrophilic substitution reactions? Will it allow an electrophile to come and attack here? No, isn't it? Already it has formed a salt. So, electrophilic substitution reactions, or the electrophile does not approach the salt. Cannot. Already it is deficient here. So, electrophile cannot approach. Hence, ESR are not possible. That's a simple question, and the way you explain is important. How much of a concept you know, writing on the paper is important. So let us come back and see one more concept, which is again related to your physical properties, that is your boiling point. Earlier we have seen a question based on solubility. Now this is boiling point. Let's see. They've asked me amines have boiling point higher than hydrocarbons. Okay, they've given me a condition saying that amines have higher boiling point. Okay, now what I have to reason this question. What basis? But lower than alcohols and carboxylic acids of comparable masses. Okay, simple thing. Whenever they ask you about solubility, try to speak in terms of hydrogen bonding. First point. Whenever they ask you in terms of boiling point, also speak in terms of hydrogen bond. That is easier way of answering. Now, simple. What should I do? I have to take amines. Now, this is amines have lower boiling point than alcohols and carboxylic acids. This is what they have written. Alcohols and carboxylic acids I have to show. So what basis did I say? This is your boiling point. I said based on hydrogen bonding. Now amines, what is happening whenever I have to see or show this hydrogen bonding is formed between hydrogen and nitrogen of your amines. This is what is your amines, isn't it? So what is this? Hydrogen and nitrogen. So hydrogen and nitrogen. Let us come back and see. Here, when I have to see in case of alcohols or carboxylic acids. Okay, let us see alcohols. Oxygen, hydrogen. Now this is your water. This is going to form a hydrogen bonding between alcohol. So your alcoholic group, as we said, this is alcohol, ROH, isn't it? Now H faces oxygen. Your this one, if I have to take this, O, right, and R. Now what is happening here? Hydrogen bonding is between oxygen and hydrogen. So no, so what are we observing? We are observing that your hydrogen bonding here is between nitrogen and hydrogen. Your hydrogen, even carboxylic acid also same, no? Yes. So here the hydrogen bonding is between nitrogen and hydrogen. Here oxygen and hydrogen. Now which is more electronegative? Nitrogen is less electronegative than oxygen. Less electronegative than oxygen. First important point. When it is less electronegative, tell me the bonds are strong or weak, because if it is less negative, the pulling capacity is, the bond formation is also weak, isn't it? If it is higher electronegative like oxygen, it's going to pull the nucleus, and strong bond is formed between these two. But here it is less electronegative than oxygen, hence lower boiling point than as alcohols and acids. That's it. That should be your answer. This is your keyword, less electronegative atom. That is your most important keyword, and you can finish up your answer. Right, so let us come back and see this question, one more question based on your boiling points. So we've understood one concept. What is the concept? Whenever there is hydrogen bonding done, and that hydrogen bonding again, they vary between a nitrogen atom and an oxygen atom. So nitrogen is less electronegative, so the particular boiling point was less compared to your alcohols and carboxylic acids. Now we'll come back to one more concept. What do they give us? Compare the boiling points among isomeric amines. What are isomeric amines? Basically, your amines, like your primary, having the same isomer means same unit. Mer means unit. Just like your primary, secondary, and tertiary amines. Primary, secondary, and tertiary are called isomeric amines. Done. So this is one way of questioning. Second thing, they've given us a particular formula and they ask us to particular name of the particular name of this amine and ask us to compare. Let's see. Both are the same. First of all, we'll write what are isomeric amines. Isomeric amines are basically your primary amine, secondary amine, and tertiary amine. Isomeric amines. Okay, what actually is this primary amine? Primary amine is nothing but nitrogen, yes, with one alkyl group and two hydrogens. Done. Secondary amine is nitrogen with two alkyl group and one hydrogen. Tertiary amine is one nitrogen with three alkyl group and no hydrogen. These are isomeric amines, right? Simple. Now they said compare the boiling point. Now when I have to compare the boiling point, most important, primary amines have more boiling point compared to secondary. Secondary amines have more boiling point compared to tertiary. What is the reason when I have to reason? Okay, first we'll make this as a box because basic information have written. So what is the reason? When I have to write the reason, we very well know boiling point depends upon your hydrogen bonding. Yes, isn't it? Now when I have to see the primary amine, you have two sites for hydrogen bonding. Yes, so when the hydrogen bonding is more, automatically the boiling point will be more. Yes, two sides. Done. Now here there is no hydrogen in it to form hydrogen bonding. So that basic important thing is when I have to speak about primary amine, when I am writing the reason, in primary amine you have formation of, okay, let us write this hydrogen on this side. Intermolecular hydrogen bonding. Just see. This is nitrogen, isn't it? This is lone pair of electron. This is going to form a hydrogen bonding with H. Now this is N. Now link it with H. Now this part is written here. Now left over is nitrogen, R and H. Now again, here nitrogen is here. Link it with one more hydrogen, N, R, H. So this type of bond is called intermolecular hydrogen bonding. Inter means between two. Intermolecular hydrogen bonding. So now, because of this intermolecular hydrogen bonding, what will happen? They get associated. When they get associated, automatically boiling point increases. Yes or no? Simple. It's the same story. This is your which amine? This is your primary amine. Now, in tertiary amine, do we have intermolecular hydrogen bonding? Can it form? It can't form. So write that reason. Now let us write that reason. This is primary amine. In tertiary amine, no intermolecular hydrogen bonding is observed. Hence, lower BP. Simple. I have written this reason. First question is over. So first done. I wrote the reason. I wrote the concept. I gave the reason. Now let us come back to the next question. So with this concept, they asked me to compare between these two. Now in these two, let us erase this part of the board. Yes. What do I have in this is part B. Why does propylamine have higher boiling point? Let us write what is propylamine. This is CH3, CH2. Propylamine. Done. They've asked me N dimethyl methanamine. Okay, it's simple for compound. There's nothing big logic in this. I'm writing this compound here. So they said N and N, both the terminus you have dimethyl. So they said amine. So write N, nitrogen, methyl, CH3, dimethyl, N, methanamine, they said. So again, methyl group, done. Let's see, 1, 2, 3, 4, 5, 6, 7 and 8. And this is your N dimethyl methanamine. Done. Yes. So now what are you observing in this particular thing? This is a primary amine, isn't it? Because the group with 2 hydrogens, this is your primary amine. When I have to compare this one, this is your tertiary amine. Now, as we have said, primary, because of 2 sites of hydrogen bonding, it has more boiling point. Tertiary doesn't have any hydrogen to form boiling point, so it will have more compared to this. Yes, this is what. So the simple, this will have more boiling point compared to this. Reason is the same, because of intermolecular hydrogen bonding. Here, absence of intermolecular hydrogen bond. That's it. Simple. I have written the reason for both general way as well as specific examples. So let us come back. Now we have done the physical properties, that is your solubility, boiling point. I have done certain questions which are more frequently asked. Now let us come back to the main concept, that is your chemical properties. From now we'll be doing so many reasoning questions, so it's easy for you to solve it in the exam. Now, along with that, I'll also be doing certain reasoning questions based on their chemical reactions also. Right. So when I have to study about chemical properties, the first important chemical property is basic nature of amines. So in your chemical properties, there are certain reactions which are common to all the amines and certain which are specific to primary amines, secondary and tertiary. So now I'm going to teach you which are common to all types of amines, that is your primary, secondary and tertiary. So basic nature, when I have to speak, how is this asked in the exam? They may either directly ask you, explain the basic nature of amines, or they may ask you in this way. What is that question? Is water less basic than amines, or either way, are amines more basic than water? Or it's the same question, right? Amines more basic than water. Why? If yes, why? Let us reason the question. Now, most important thing, whenever a basic nature or basic strength is explained or acidic strength is explained, we explain in terms of two important things. What are those? We are going to use for, suppose let us say acidic strength. I have to explain acidic strength of a particular acid, then I use a term Ka, acid ionization constant. Now, what are we doing? We are going to use, we are explain about basic strength. So, basic strength is explained by base ionization constant. So, let us write this. This is called base ionization constant. Done. Let's start. Now, I have to prove whether it is basic or not. First important thing, remember in your mind, all amines, I am writing in caps, all amines are more basic than water. First, if you understand, then basic than water. If you understand this, everything is easy. Basic than water. So, let me put this in a box. Why are they basic? Because suppose if I take primary amine is one alkyl group and two hydrogens. Secondary amine is two alkyl groups and one hydrogen. Tertiary is three alkyl groups and one. So let us name primary, secondary and tertiary. Suppose if I am trying to dissolve this in water. So water, HOH. I am this also trying to dissolve in water. Now observe. What is happening here? Amine, when you are trying to dissolve in water, first amine tries to form two important compounds. One is this one. Just see what am I doing? I am trying to break the bond here in hydrogen between hydrogen and oxygen. And what products do I get? I get an equilibrium product. What is that? Just observe. RNH3 plus RNH3 plus OH minus. First one. Second case, R2NH2 plus OH minus. Third case in tertiary, RNH plus OH minus. Now what is happening? Your amines, now I said they're more basic. What are they doing? These amines are trying to, first of all important thing, these amines are releasing OH minus when dissolved in water. That means what are they trying to do? They are or they are protonating. They are going to take out that proton from water and they are releasing that OH minus. Aren't they stronger than water? Simple, isn't it? Amine is trying to break the bond, pick up that hydrogen and finally release out that OH minus from water. That is the reason they are more basic than water. So what can we say? Amines release OH minus when dissolved in water. So that's the reason they are more basic in nature. So remember this concept, release of OH minus ion. So when I have to write that particular thing, Kb for this is equal to concentration of the products are NH3 plus by OH minus divided by your R and H2 for the first one. For the second one, Kb is equal to concentration of R and H2 plus into OH minus divided by the product R2 NH. For tertiary, Kb is equal to R3NH plus OH minus divided by your product R3N. Now, simple. What did I say just now? Because they are removing that or releasing that OH minus in water molecule, they are more stronger than water, isn't it? Amines. Now, I've written three important values. Those are base ionization constant for primary amine, base ionization constant for tertiary amine, secondary amine, and base ionization for tertiary amine. So, where am I going to use this value? Basically, we are going to relate or take these values and just see everything has a different value. When you try to solve, take this concentration, take this and take this, solve this particular formula, you get certain values. Now we are going to see a new concept called pKb. pKb is equal to negative logarithm of Kb. What is this pKb value? That means when I am trying to get this value from here, I am going to take negative value of this. then I'm going to get pKb. Simple, okay? Yes, so we get this experimental value from here, take negative log of that value, I get pKb. What is the concept? Smaller, again I'm writing in caps, smaller the pKb, stronger is the base. Stronger is the base. Remember this. If you understand this concept, it's easy. pKb value should be smaller. That means Kb value should be larger, isn't it? So pKb, if the value is very small in the question which I will be dealing, if you have the pKb value very less, that means it is the strongest base. Yes, but opposite the other way, Kb should be higher. So pKb should be lower, Kb should be higher, then it is basic in nature. So this is how we are going to explain. So I think we'll write why is amines, because amines release or produce OH minus when dissolved in water. Hence are more basic than water. Okay, this is how you're going to write or explain this concept. Right. So let us come back and see one question based on your basic nature. So what did we learn already? Smaller the pKb value, stronger is the basic nature. Stronger is that base, right? The strength of the base is higher. Now, if one question is given to us like this, why is dimethylamine more basic than ammonia? Done. Here they've given us pKb value. So blindly I can write the answer, isn't it? Because smaller the pKb value, stronger is the base. So when pKb is given to me, I can write this concept. Smaller pKb value, stronger is the base. So in both the things, first one is for dimethylamine 3.27. Second one is 4.74 for ammonia. Simple. Since pKb of dimethylamine is lesser than pKb of ammonia, dimethylamine, okay, let us write, this is first box, let us put this first box. Let us make this a second box. It's easy for the examiner to correct your answer. Dimethylamine is more basic. This is your order of basicity. You have to write it down. Order of basicity, more basic than ammonia. That's it. This is your answer. So see the pKb value and done. Suppose in the exam they have not given you pKb value. What should you do? Simple. So let us erase this. Now concept is they've not given me this. Now what should I do? Yes. You should simply remember this logic. Order of basicity of amines. Yes. Simple. Always remember your secondary amine is a stronger base compared to primary amine. Primary amine is a stronger base compared to tertiary amine. Tertiary amine is a stronger base compared to ammonia. That's it. Now, how can I relate to the question? Suppose if I'm taking this concept and relating to the question, that ammonia is this ammonia here on the order. Dimethylamine they've given. Let us write the formula because structure. Let us write the structure. Dimethylamine, right? Dimethylamine. Done. Now this dimethylamine, okay, they said what is this particular thing? Okay, what is the mistake did I do here? Amine they said, so one hydrogen, isn't it? Because you have a lone pair of electron here. Yes, so remember what type of amine is this? Two alkyl groups and one hydrogen. Two alkyl, one hydrogen is which amine? Secondary amine. So obviously secondary amine, as I said, greater BP than ammonia. This is how you will do it. So now what did we do? We've already started with the chemical properties, where I explained the basic nature. First concept which I explained you is study on terms or on basis of pKb and Kb values. I said smaller the pKb, more is basicity. After that, I went into a concept where I related between primary, secondary and tertiary in ammonia. What logic did we say? Always remember, secondary has the higher, this is highly basic than primary. After primary, primary is more basic than tertiary is more basic than ammonia. Now, if they have not given me like that, if they give me the question like this, why are aliphatic amines more basic than ammonia? I have to reason this question. First important thing, I have to compare aliphatic and amine. I hope you all know what is aliphatic. Amine, your alkyl amine. That is a primary, secondary and tertiary. I'm going to take that ammonia first. Draw the structure. Nitrogen, hydrogen, 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 lone pair. Done. What is this? This is your ammonia. And let me write primary. Primary is basically your nitrogen, always lone pair. Yes, primary is one alkyl group and two hydrogens. This is primary amine. I'm coming back to the second aliphatic amine, secondary. Hydrogen, two alkyl groups, lone pair is secondary amine. Third one, nitrogen, with three alkyl groups and a lone pair, tertiary amine. Simple. Now, they asked me ammonia is more, these three are more basic than this itself. That means indirectly it is less basic, isn't it? Why? Now, what is happening here? There is only one lone pair of electron to donate. So when something donates, then only it is basic in nature, isn't it? Now, here you have one alkyl group. What is it doing? It is R is an electron releasing group. That means what effect is it showing? Plus I effect. Here, how many alkyl groups you have? One alkyl here. Again, plus I effect. Here, 1, 2, 3. 3 alkyl groups, plus I effect. Now just tell me, here when the alkyl group is trying to donate, what will happen to the electron density here? It becomes more, isn't it? Here how many are donating? 2 are donating, and the electron density will become on nitrogen, around nitrogen becomes more. Here how many are donating? Here 3 are donating and the electron density becomes more. Yes, but remember, I have to compare between these three things and ammonia. So ammonia, do you have any alkyl groups for electron releasing? No, isn't it? Yes. Now this is your reason. Start writing the reason here. Aliphatic amines are more basic than ammonia due to electron releasing alkyl. Okay, let us not write shortcuts. Electron releasing alkyl groups. So what will happen when they release electrons? So electron release more electron density increases on nitrogen. When more electron density increases on nitrogen, what will happen? Hence, release of electrons becomes easy. When electrons releasing becomes easy, what will happen to the basicity? Yes, hence basicity increases. That's it. But are you finding that in ammonia? Do you have in ammonia alkyl groups? No, isn't it? So aliphatic amines are more basic than ammonia due to electron releasing alkyl groups, which which increases. Okay, let me write which more, no, which I'm linking that sentence here, due to electron releasing alkyl group, which increases. This is better, I believe. Yes. Now let us read again. Aliphatic amines are more basic than ammonia due to electron releasing group, which increases electron density in nitrogen. Yes. And hence release of electrons become easier than basicity. But R groups are absent in ammonia. That's it. This is your answer. Yes. So now let us come back and learn this one more concept. So till now I taught you based on your pKb value, then I taught you based on alkyl group. Now suppose if this question is asked, compare the basic strength of primary, secondary and tertiary, you have to be very keen in answering this question. What? Basically when I taught you the earlier topic, I said based on your plus I effect, that is your electron releasing effect, tertiary is more basic than secondary, more basic than primary, which is more basic than ammonia, because more of the alkyl groups, more is the electron density on nitrogen, more it can release the electrons, more is the basicity. Done. Now there is one more concept which I am going to explain you, that is hydration effect. Hydration effect. Done. Here in hydration effect, the order would be your primary greater than secondary, greater than tertiary, greater than ammonia. When I'm going to combine both the effects, plus I effect and hydration effect, the actual order, the observed order is always, you have to answer on this basis only your questions. Observed order would be secondary greater than, primary greater than, tertiary greater than ammonia. Ma'am, what is this? Let us see. Now I've already explained plus I effect in the earlier video. Now let us see hydration. So hydration effect is nothing. Simple. Let's see. In hydration effect or stabilization of ammonium cation, suppose if I'm taking a primary amine, I am dissolving it in water. What am I getting? This is going to break the bond, and NH2 combines with hydrogen and forms RNH3 plus OH minus. That's there. When I take secondary amine, this is going to combine with water and it forms RNH2 plus OH minus. When I take tertiary, R in water, it's going to combine with this and forms RNH plus OH minus. Now what actually is happening inside this molecule? Now I took this is called ammonium cation. Now this hydrogen, when it's dissolved in water, now this is like this. Okay, this has 3 hydrogen atoms. Primary has 3 hydrogen atoms. Now when I have to show this secondary, it has 2 hydrogen atoms. When I have to show tertiary, it has only 1 hydrogen atom. These 3 hydrogen atoms are going to form hydrogen bonding with water. Just see, here one oxygen, here one oxygen. Yes. Now this is your H. Water molecule. Here, how many? 1 oxygen from here, water molecule. 1 oxygen from here, hydrogen bonding, water molecule. Here there's only 1 hydrogen atom to form water hydrogen bonding. Now observe carefully. In primary amine, you have 3 hydrogen atoms to stabilize the molecule. Isn't it more stable? Yes, this is most stable. In secondary amine, you have only 2 hydrogen atoms to get stabilized by hydrogen bonding. In tertiary, you have only 1 hydrogen atom to get stabilized by hydrogen bonding. So this is least stable. Now what am I trying to explain? More number of hydrogen atoms, more is the stability. Lesser number of hydrogen atoms, lesser is the stability. Because less number of hydrogen bonds, let us write more number of hydrogen atoms where in primary amine. Higher stability. The second one, less number of hydrogen atoms, that is in your tertiary amine. Low stability. Now simple. So based on this hydration effect, this is what I did. So your hydration effect is explaining me this concept. That is what I wrote, that reason. So more number, 3 are forming 3 hydrogen bondings. Here only 2 hydrogen bonding, here only 1 hydrogen bonding. So this whole concept is with forming a bond with water molecule is called hydration effect. Because of this hydration effect, primary has 3 stabilizing factors, 3 hydrogen atoms, hence this is more basic. Here then comes your secondary because it has 2. Then comes your tertiary and ammonia. Obviously, it is the last. So this is how you're going to explain. Plus I effect I explained in the earlier video. Hydration effect I've explained in this video. You're combining both. When I've combined both and seen the values, this was the final order. Secondary greater than primary, greater than tertiary, then ammonia. So remember, in the exam, you have to apply this if they're not given specifically. If they give you based on I effect, you have to apply this. If they say based on hydration effect, you have to apply that. Now, I tried to explain you basicity between primary, secondary, tertiary. I did that concept. Then I explained you between ammonia and aliphatic amines, that also. Then I explained you based on hydration effect, that also done. I explained you basicity depending on the pKb value, that also done. Now, let us come back and start comparing your aliphatic amines and aromatic amines, that is your aniline. So what are they asking us? Compare basic strength between alkyl and aryl amine. Okay, always remember one important thing. Yes, aryl amines, you have to remember this concept, then only I can teach you the whole thing. Aryl amines are less basic than aliphatic amines. If you remember this, the whole concept is easy. Remember this. Less basic nature. I'll explain the reason also. Now let us see this question. Suppose if they're not giving like this, they may give you like this also. You should be very careful. Now I know this concept. Apply this concept to this. Compared to NN dimethyl aniline. So let us write NN dimethyl aniline. So this is your benzene ring. This is your nitrogen. Basically this is aniline, isn't it? Now to this nitrogen you have dimethyl it. So what should I do? I have to take out these two hydrogens and add CH3 and CH3. See here, NN dimethyl aniline. Done. This is the first one. Second one is aniline. Third one is methylamine. This is methylamine. Done? Yes. So now they're asking us which is more basic. Now what is this concept? Aryl amines are less basic than aliphatic amines. This is aliphatic amine. These are aryl amines with benzene ring. Whenever you see benzene ring, these are aryl amines, isn't it? Now they said this is more. This is more. Okay, done. Now I have a problem. I have to compare between this and this. Remember one important thing. Whenever your nitrogen atom is directly attached, here also it is directly attached, but important thing, you have two electron releasing groups. Here you don't have. Correct? So the one which is directly attached to the benzene ring, that will be, when I compare to this, will be less basic compared to this particular thing. What am I trying to say? When I have to compare between this and this compound and this compound, I see aniline is less basic than NN dimethyl aniline. That means if I have to write the order, right? First, let us number this is 1, let us number this is 2, let us number this is 3. So I'm writing in the increasing order. 1 greater than 2 greater than 3. Let us write the reason now. Reason is, now here RNH2, the first one, you have electron releasing group of plus I effect. When I have to see this ring, benzene ring, ARNH2, you have electron release, electron withdrawing group. Here what is electron releasing group? R is releasing the electrons. Here what is electron withdrawing? This one. Your ring is going to withdraw the electrons. Electron withdrawing group minus I effect, that is AR. When I have to see these and this, here you don't have any other group, and this hydrogen is directly attached to nitrogen. This nitrogen is attached to benzene ring. This is more electron withdrawing. It tries to drag the electrons. If it is trying to drag the electron, will it release electrons? It will not. If it is not releasing electrons, is it more basic or less basic? Less basic, isn't it? Something, if it releases electrons only, it is more basic. Remember that. So here When I have to compare all the three, let us come to a conclusion now. Directly attached, so will not release electrons because of minus I. Okay, electron withdrawing AR group. This will release compared to this because you have two electron releasing groups, but here you have methyl group, no benzene ring, it is completely releasing electrons. So electron density on nitrogen increases, thus it releases electrons. So this is your concept. So remember always, aryl amines, most important, are more less basic. Point number 1. Point number 2, if you find any methyl group arranged to attach to benzene ring, try to take this as more basic compared to directly attached nitrogen to benzene ring. So let us see this question, a little bit different compared to the earlier ones. Let's see. What did they ask me? Compared to aniline and anilinium ion, which is more stable. Okay, what is anilinium ion? We'll see now. So whenever I have to speak about anilinium ion, first I have to take aniline. This is your aniline. When I dissolve this in water, yes, aniline being, it's a weak base, I know that, isn't it? It's a weak base. So what does it do? It's going to drag or pick this hydrogen H plus ion from here. So when this picks up H plus ion from here, breaking this bond, this is going to form a new ion called, now just see, NH2 plus H becomes NH3 plus. And OH minus is released. Okay, because it is releasing OH minus, it's a weak base. Now, this is called anilinium ion. Anilinium ion. So, what did they ask me? Compared to aniline and anilinium ion, which is more stable. So, on what basis do I explain stability? It's simple but resonance, isn't it? In earlier video, I've shown you aryl amines are less basic than aliphatic because of resonance. So, here, amine, when I have to see, it shows resonating structures or it shows resonance. Please watch the previous video. I've shown you the resonating structures. But here when I have to see anilinium ion, it can't show resonance because it can't further accept proton or show any resonating structures, isn't it? Cannot show because there is plus already. If here it has lone pair of electron, that's different. The sense or these two electrons will shift here, this will shift here and that way. But here already it has attained a positive charge. It is deficient of electrons, so cannot show resonating structures. Resonating structures. Cannot show resonating structures. So whichever shows resonance is more stabilized. This does not show resonance, so it is less stable. So that is the reason compared to aniline and anilinium ion. So which is more stable? As according to the reason, aniline is more stable than anilinium ion due to resonance. Now let's come back and study the effect of substituents on basicity. So let us write the heading, effect of substituents on basicity of amines. Now, this is your grade 11th recent concept where you have studied what are electron withdrawing group, electron releasing. So I have listed out certain examples. Electron withdrawing group examples are 3, electron releasing. I have picked up 3 examples. Now important thing you have to remember, if you have your aniline, right, this is your NH2. When this is picking up proton, okay, from water molecule, it's going to get converted to your anilinium ion. This is what I have written in the earlier video. This is going to become anilinium ion, which is less stable because it doesn't show resonance. Now suppose to this particular aniline or anilinium ion, if you have electron withdrawing groups, okay, I'm going to write electron withdrawing. Just see here, they're going to drag. I'm going to write electron withdrawing groups. So this electron withdrawing group, as I said, it can be nitro, cyano, and X. It can be anything. Here also, if you have electron withdrawing groups, Like as I said, let me write E. Okay, I'll write EWE like this. Better. Yes, electron withdrawing groups. E can be nitro, cyano, and X. So whenever you have electron withdrawing group, they are going to drag the electrons from here. It will pull the electrons towards themselves. If anything, any of these are present in this here, anywhere, if they are present on the benzene ring, they are going to drag the electron density, and what will happen to the basicity? They are less basic. Why? Because when they are trying to drag the electron, when something releases electrons only, it is acid, basic in nature. But when this is trying to drag the electrons towards it, so this is less basic. So what concept should you write? Electron withdrawing groups, if they are present, then basic. Okay, less basic. Let us write less basic. That is what I have written here. Now, suppose in this particular thing, the same aniline, if you have electron releasing groups. So, what are electron releasing groups? I have written here OCH3, your CH3, and your NH2. If you have electron releasing group, the same story here also. And selenium ion also the same thing. NH3 plus electron releasing groups, E groups. I said when they are trying to release the electrons, or because of this, lot of electron cloud increases on nitrogen. When lot of electron cloud increases on nitrogen, it can easily release electrons. When it easily releases electrons, it is more basic in nature. So what can I conclude? Important, ERG groups present, it is more basic in nature. Remember, because I'll be doing certain questions where I'll be asking you methoxy, in that way amino, or your cyano, which is more stronger, which is more basic. So this is the concept, basic concept. When I try to solve the questions based on that, you will understand the whole thing. Remember this whenever you see the compounds, and you have to memorize such groups, please. The reaction, most of 90% of the chapter is done. If I have to say specifically, 95% of the chapter is done. We are left with last part of the chapter. Then I'll be doing so many reasoning questions. Then I'll come back to your board papers. Now when I have to see the reactions due to benzene ring, now simple. Your amine or aromatic amines, that your aniline. Aniline basically shows two types of reactions. One is involving benzene. That is, that first type of reaction is reactions involving benzene ring, and in that reactions involving benzene ring, the first type of reaction I am going to teach you is halogenation reaction. After that, you'll also be learning about nitration reaction, and you're also going to learn about sulfonation reaction. Done. When I have to learn the second category of reactions, it is going to show us a coupling reaction, which I've already taught. Yes, simple, with aniline coupled. Okay, let us see that also. So coupling reaction also done. So now this is your basic thing. First we will learn all these three and then come back to your coupling reaction. So let us come back and start with your first reactions involving benzene ring, that is your halogenation. So here we are going to add bromine, that is your bromination. So what happens whenever you are taking, let us write bromination now. That is your addition of bromine. Done. So whenever you are taking aniline, simple. Aniline reacts with your bromine without any catalyst. Directly you're going to add bromine to aniline. It forms 2,4,6 tribromo product. So nothing, no catalyst required. I'm going to add this. Directly, how many I'm going to add? 3. That means total of 6. Now observe carefully. As I said, due to resonance, ortho, para and ortho positions are opened up. Now this is the site where bromine goes and acts. So I said it immediately reacts with bromine. So you get aniline with ortho, para and ortho positions. All are occupied because those are the sites of where we have shown resonance. So this compound is called 2,4,6. See, this is 1, 2, 3, 4, 5, 6. So 2,4,6 tribromo aniline. Done. What else is left? 3 are over. I still have 3. So the hydrogens which are there present at this particular sites here, here and here, those will come out as 3HBr. Now observe carefully. 3 plus 3, 6 bromines are out and 3 hydrogens which are there in the ring are this. So this is your compound. Now at a stretch you've got 2, 4, 6. Now suppose if you want mono substituted halogenated compound, what should you do? See that. Now this is for all together. Now second, to obtain mono substituted anilines, this is the procedure. Please observe carefully. First, what are we going to do? You are going to take aniline. To this aniline, you are going to add, or you are going to allow it to undergo acetylation process. Acetylation. When you are allowing it to undergo acetylation, this will form a product called acetanilide. Acetanilide. This acetanilide, further you are going to allow it to undergo halogenation, that is your bromine in the presence of acetic acid. When you are allowing it to undergo this process, halogenation process, okay, I have to write halogenation here. Acetylation is addition of CH3COCl, acetyl group. Then when you are trying to halogenate it, acetanilide will get converted into 2 products. One is orthobromoacetanilide and parabromoacetanilide. This on further hydrolysis, when you're further hydrolyzing it, the acetic acid comes out and you get orthobromoaniline and parabromoaniline. Okay, this is your thing. So let us write orthobromoaniline. This is your compound. Let's write the reaction now. So first important thing, let us take aniline. I'm going to say I introduce acetylation. Acetylation processes, addition of CH3COCl, try to write it in this way. So this H and this Cl comes out as minus HCl. What are we left with? Only NH, isn't it? NHCOCH3. Your ring with NHCOCH3. This is called acetanilide. Now this acetanilide, now we are going to halogenate it. This is here. You are going to allow it to undergo halogenation. So halogenation, which halogen are you getting? You are trying to get bromine with acetic acid. So this bromine goes and adds to that. You get 2 products, I said. One is NHCOCH3, that is orthobromoacetanilide, plus you get one more product, that is parabromoacetanilide. Orthobromoacetanilide, parabromoacetanilide, I have written here. This is the minor product, ortho always, para is major. Now further what do? They are going to hydrolyze this, H plus water. When you're hydrolyzing it, observe carefully, this comes out as acetic acid, CH3COOH. Now left over, your ammonia is, NH is here, NH is here. That picks up hydrogen from here and becomes NH2 and NH2. So what do I get? I get aniline. This is orthobromoaniline 1. Second one is aniline with parabromoaniline. So let's see whether I've written correctly or not. This is your actual base reaction which you have to remember and go. This is your base reaction. Just see. First aniline. On acetylation, hope this is CO, hope it is clear. Yes, acetylation, what is removed out? HCl. So I get acetanilide. To this acetanilide I am going to halogenate it. Halogenation, bromine in the presence of acetic acid. Then you get a mixture of 2 products. One is orthobromoacetanilide, orthobromo acetanilide and para-bromoacetanilide. After that, you're hydrolyzing it. Then acetic acid is out. I've not just balanced, I've written acetic acid out. And aniline with orthobromoaniline, separate product. Para-bromoaniline. This is major. This is minor. So this is your halogenation reaction of aniline. So let us come back and do the nitration property of your aniline. So till now we've studied the halogenation, that is your bromination of aniline. Let us start with nitration. So whenever in the exam, if you're asked to do the nitration procedure, for nitration of aniline, you require a nitrating agent. That is understood, isn't it? So the nitrating mixture which we are going to use is concentrated HNO3 plus concentrated H2SO4. We already know the electrophile which this is going to supply. You have studied in your grade 11 even the small mechanism where you're shifting the NO2 plus group, right? So NO2 plus cation, I'm sorry. So the electrophile which is going to supply is NO2 plus. Done. Now first important thing, aniline does not undergo nitration directly. First reason is aniline, when you're trying to allow it, or if you're allowing it to undergo nitration, it just directly gets oxidized. Most important thing, yes, you have to note it somewhere. Aniline gets oxidized on direct nitration. That's why what do we do? First we are going to introduce or allow it to undergo acetylation process. So this is again the same like earlier one. First you acetyl. Why are we allowing it to undergo acetylation? Then with acetylation we'll lock this compound, this particular thing. Yeah, and amine I'm going to lock. Then I can easily nitrate it. So acetylation can be performed by using CH3COCl or even acetic anhydride also. So here what am I going to do? See, either CH3COCl or here I'm going to use acetic anhydride. This is acetic anhydride. So what happens? This acetic anhydride, this will go and break up this bond. And what do you get? You get first, this will lock amine. It will form NHCOCH3. What's the earlier video? I've shown you how HCl has gone out. And so now what is this compound? This is called acetanilide. So this acetanilide, now I'm going to introduce this nitrating mixture, right? So that will supply your NO2. So you are going to add concentrated HNO3 and concentrated sulfuric acid. When you're adding these two, the electrophile NO2 will go and just occupy the ortho position, para and ortho. You'll get both the products. Because of resonance, we have already seen this is already locked NHCOCH3. You get one at ortho position. This is ortho-nitroacetanilide plus para-nitroacetanilide. These two are the products. Acetanilide. Done. So still our nitroaniline is not formed. So this further, now which is my minor in this is minor product, this is major product. Then we are going to further hydrolyze it. Yes. When you have further hydrolyzing it, we very well know this particular acetic acid comes out. Here also you have CH3COOH. If I take 2 moles, suppose if I take, let us assume I'm taking 2 moles. 1 OH here, 1 OH here, 1 hydrogen here, 1 hydrogen here. So what do I get? Again I get 2 products. One is here aniline, that is ortho-nitroaniline, O-nitroaniline, which is a minor product. After that, I am also going to get para-nitroaniline, which is a major product. this is your major product. That's it. So this is how you're going to do nitration. Never in the exam, please don't directly take your HNO3 and do the nitrating procedure. Wrong. You lose mark for that. First try to form acetanilide, then only convert into orthopara. After orthopara, further hydrolysis. So what is the reason? Aniline undergoes, I'm writing the same reason here, aniline. Okay, aniline. What in aniline? What is this? Your whole thing, amine, right? And this amine part undergoes oxidation. Hence, it is allowed to form these compounds. Right. So now let us come back and do the last reaction, which is involving a benzene ring, that is a sulfonation. So we'll also do a question regarding the Friedel-Crafts alkylation and acylation. Let's come back and do this. So whenever you speak about sulfonation of aniline, so what did we learn earlier when you're doing your nitration? I said it is not directly going to, like nitrating mixture will not directly go and attack aniline and form orthopara, but first forms acetanilide, then gradually it's going to form. Here also you have a concept. Let's see that. So in sulfonation, what do you require? What supplies as the electrophile? That is concentrated sulfuric acid. Now, so for sulfonation, as I said, you require concentrated sulfuric acid, which is going to supply SO3H as an electrophile. Sorry. So first you are going to take your aniline. What happens is, whenever you are heating aniline with sulfuric acid for the sulfonation procedure, is going to take 4 to 5 hours for aniline to form products. So to get your orthopara aniline and the benzene sulfonic acid and parabenzene sulfonic acid, to get products, it's going to take 4 to 5 hours. So let us see the procedure, what actually is happening in the reaction. First, aniline, you are going to treat it with concentrated sulfuric acid. Okay. Now see, sulfuric acid, I can write it as H and H plus plus HSO4 minus. Yes, done. In the step 1, this aniline is going to pick this H plus. And how is it going to join? It's going to just become NH3 plus and your HSO4 minus. Now this is sulfate, isn't it? Now just see how to name this. Aniline hydrogen sulfate. Done. Now to this hydrogen sulfate, now gradually what's going to happen? You are going to remove water from this. Where are you removing? Observe. 2 hydrogens from here, 1 oxygen from here. Once again, remove water. 2 hydrogens from here, 1 oxygen from here is removed. What do I get then? I get a compound which is like this. NH3 have lost 2 hydrogens. It's going to become NH. SO4 has lost 1 oxygen, so this is going to become SO3H. Now this compound is called sulfamic acid. Remember this, sulfamic acid. Now to this sulfamic acid, now I'm going to heat it to 60 degrees centigrade. Then there's a shift of SOH bond and you get NH2 and SO3H, the ortho position. What do we get? We have got ortho position sulfonic acid. Now let us name ortho amino benzene sulfonic acid. Done. Now this ortho amino benzene sulfonic acid, when you're increasing the temperature to 180 degrees, you get a compound called para amino benzene sulfonic acid. This is sulfamic acid. This is sulfonic acid. So this is how is your sulfonation done for in case of aniline. In the exam, please don't try to directly write ortho para. Don't do that. You lose mark. Though you know the concept, if you're not presenting it properly, you lose mark. So this is the procedure for sulfonation of aniline. Right. So let us come back and see such questions. Now, till now, what did we do? Arrange the following, compare, increasing order, decreasing order. Now, certain FAQ questions will be quite common like this. By in your whole chapter, there will nothing of direct question will be asked to you. Remember, either they may give you identify A, B, C, where I've done the questions already, or they may give you in this way to complete the reaction. Now, as soon as such reactions are given to you, just observe carefully. Now, what is this particular reactant? Chloroform in alcoholic KOH. Which reaction did we learn? Chloroform in alcoholic KOH, that is studied under carbylamine reaction. So, take your pen and just write here carbylamine reaction. Okay, done. Next, what did we see? What are we seeing here? H3PO2 and water, and one more, yeah, ethanol. Both H3PO2 and ethanol, both are reducing agents. I've already done this question under BDC reactions. So remember, H3PO2 is a reducing agent. Done. Ethanol also is a reducing agent. Done. Let us come back. What is concentrated sulfuric acid used? Where is it used? It is used in sulfonation of aniline, isn't it? Remember, we have done sulfonation step-by-step reactions. So, sulfuric acid is used as sulfonation, for sulfonation. And this is done. We are left with this. What is Fe in HCl? Fe in HCl, metal acid. It is also a reducing agent. Sn by HCl, Fe by HCl. Didn't we learn this? We've learned this. Now let's come back and do. In carbylamine reaction, the most important product is formation of isocyanide. So learn carbylamine first there, then only come back to these questions, please. Otherwise, you will not understand the concept. So this, say aniline in carbylamine reaction first gets converted to isocyanide. Please, yes, the leftover you will get KCl and water, both 3 and 3. Yes, this is your carbylamine reaction, the final product. Now, when I have to see this particular reaction, I very well know whenever you have reducing agents like this, whenever BDC reacts with these reducing agents, only one important common thing, simple, just remember only two you have for your CBSE, your NCRT. One is H3PO2 and one is ethanol, right? H3PO2 being a reducing agent, it gets converted to higher oxidation state, that is H3PO3. Ethanol being a reducing agent, it gets oxidized, that is what is a reducing agent. Alcohols and oxidation gives aldehydes. CH3, CHO, aldehydes. Please remember, alcohol and oxidation gives aldehydes. H3PO2 to the higher oxidation state, H3PO3. First you try to write these two, and all are common now, simple. So this one gets converted to benzene here. This also gets converted to benzene. I have already done one video on this. Please watch that. Apart from this, you have nitrogen. Here also nitrogen, because when you heat BDC, you'll get nitrogen gas out, isn't it? Now, along with this, your Cl is there in BDC, HCl, HCl. That's it. Common reactions. Only thing is this. You have to concentrate on this product. Remaining all are same. Now, next, this is your sulfonation, isn't it? So, what do you do in sulfonation? You'll get two products, ortho product and para product, which is the major product. So try to write the major product, simple. You have your aniline, nothing, don't show the whole mechanism which I've shown earlier. SO3H. That's it, major. Let's come back. Now this is a reducing agent, I said. So when this is a reducing agent, what will happen? It's going to remove oxygen and add hydrogen. Reducing agent, so it helps in reduction and itself gets oxidized. So it's going to add hydrogen to this. What do you get? C6H5NH2. Aniline. Simple. Once again, when such reactions are given to you, see what is given, what is its role. See what is given, its role. Its role. Everywhere try to write its role in that particular reaction, and automatically you can write the reaction. Now, let's see one more set of questions which are frequently asked in your exam. Let's read the question. They've given us arrange based on pKb values. Okay, when I've taught this concept in the earlier video, pKb values and Kb values, I said stronger bases will have lower pKb. Remember, once again, what did I say? Lower the pKb value, stronger is a base. Or another way, higher Kb, okay, it's the same, right? Because negative logarithm. Here they've asked us to write in terms of pKb. Remember, they've not given any pKb values. How will I write? So remember one thing, when such question is given to you without any values, important concept we should strike you is more of R group, alkyl group, that is your electron releasing groups. R is nothing but alkyl. More of alkyl groups, that particular thing would be stronger base. Yes, isn't it? If the base is stronger, this will have lower pKb value. This is your concept. With this concept, let us see whether I can write. Now they said arrange based on the pKb value. So let us see in such a way that based on pKb value increasing order. This would be better for you to remember. That means the stronger base with lower pKb should be written here, and the weak base with higher pKb should be written here. Why did I pick up this? Because increasing order is said. That means the pKb value should be higher at the end. Let's start. Now there is only one alkyl group here. Here there is benzene ring. Careful. Here there are two alkyl groups. Here there is again benzene ring. So benzene ring will try to drag the electrons towards itself, resonance, and will not release the electrons. So it is least basic. Whichever is least basic will have higher pKb. Come back again. Least basic. Right. Here what is happening? Electrons are involved in resonance. They are involved in resonance. When they are involved in resonance, release of electrons, is it easy or difficult? No. It's very difficult because they keep delocalizing inside. So, release of electrons is difficult. Third, hence less basic. When it is less basic, pKb will be higher pKb. Come back, see. Stronger base, lower pKb. Weak base, higher pKb. That's it. Come back. This is over. Now, the one which is stronger here. There are two alkyl groups, so this will be strongest among all. Strong base. Why strong base? Two electron releasing groups. That is like TW. Hence, highly basic. Done. Over. Now I have this is done. This is done. This is done. I have to compare this and this. Now compared to these two, there is a benzene ring here. Correct? There is alkyl group here. So this particular thing will have lower pKb. Then comes your C2H5 NH2. Then comes your C6H5 NH CH3. Now observe carefully. What did I write? Whenever you have more alkyl group, strong base, lower pKb. Whichever has electron withdrawing groups, weak base, higher pKb. So I've arranged according to the question asked. This is how you're going to do. Simple. Let's come back and do this question. They've given me methylamine solution in water reacts with ferric chloride itself, okay, solution to give a precipitate of ferric hydroxide. I have to show that reaction. So basically when I speak about methylamine, I very well know when methylamine combines with water, aqueous solution, this is going to drag this because of this. It will break, plus minus, the lone pair shift. So what do you get? You're going to get CH3, NH3 plus and OH minus. Done. Now this is released OH minus. Now they said the methylamine solution. Now methylamine solution in water reacts with ferric chloride. So ferric chloride, what happens? FeCl3, it will break up into Fe plus 3 plus 3Cl minus. Now this Fe plus 3 is going to combine with your OH minus and it's going to form a compound called hydrated ferric oxide. This is a brown color PPT. Brown color PPT. So the formula is Fe2O3 dot 3H2O. So let us balance. Iron is 2. Hydrogen is 3 2s are 6. So oxygen, if I have to balance 3 oxygens here, 3 oxygens here, 6. So this is your compound. This is what they've asked you. Most important thing, methylamine is more basic than water. That's the reason it's picking up that hydrogen towards itself, dragging that hydrogen towards itself, which is making the release of OH minus. That OH minus is react with ferric chloride. This ferric chloride dissociates. That's reacting with ferric chloride, forming a compound which is ferric or hydrated ferric oxide. That is what they've written. So we've written the PPT color also. Be very specific in the answer. So this is this answer. The concept is in the box. This is this answer. The formula is written below. Let us come back and see such type of questions. This is one more way of asking you from the amines chapter. Let's see. Show how do you prepare aniline from benzene. Normally preparations we have learned, isn't it? Now they're asking us to prepare in this way, right? Aniline from benzene. Done. So let us pick up this as first reaction, second and third. Done. First one, aniline from benzene. So I have to take first as benzene. Done. Then finally I have to prepare aniline. Now, we very well know the sequence. Always remember, nitro is converted to amine. After amine only, then cyano. I already said that day. First video, I think I told you the sequence. Benzene, then if you are converting to nitro to nitration, nitro to aniline, aniline to cyano. Done? Let's come back. So benzene, when I can use the nitrogen mixture, that is concentrated HNO3 and concentrated sulfuric acid, because that's the sequence, isn't it? This is going to supply me the electrophile NO2 plus. This electrophile will go and attack benzene at the para position, forming NO2. Now done, no, almost. See what is extra? This is nitrogen, here nitrogen, oxygen, hydrogen. So there's something which is adding this hydrogen, reducing agent. So Sn by HCl, reducing agent, is going to remove oxygen and add hydrogen to this. That's it. I've got aniline. Let us come back and do the part B. This is done. Let's come back and do this. Now what should I do? I have to prepare aniline from bromobenzene. Okay, a big reaction. Let us write aniline here. Let us come back to bromobenzene as a reactant. Now, as soon as you find bromobenzene, the first easiest way to do, the simplest method I'm giving it to you, try to add to this magnesium. When you add magnesium with an like alcoholic, this magnesium goes and adds to this, right? Why am I doing this? Because whenever you find magnesium, when you try to introduce carbon dioxide in acidic medium, one reaction was also done on this, carbon dioxide acidic medium, immediately this MgOH comes out, MgOH-Br comes out, and your carbon dioxide with this group goes and adds here. Basically this is like this, isn't it? HOH. So MgOH-Br is out, and CO, carbon dioxide and hydrogen forms your benzoic acid group. Done. Now as soon as you get benzoic acid, the simplest way to convert, use thionyl chloride to this. When you use thionyl chloride, I already said minus HCl. What is left now? It becomes your HCl is out. So CO, your sulfur, even your SO2 gas is out. So this part is done. HCl is out. And what do I get? I get no, 1 minute. Let's see. Okay, one HCl. We have one more Cl, isn't it? So you're going to get COCl. Let us come back and see whether we've done correctly. SO2, done. This is done, lost. 1H and Cl, done. This is also lost. Now we still have one more Cl here that went and got. Okay, done. This is correct. Now this is your acetyl benzyl chloride. This benzoyl chloride, its simplest way. What is compared to this one, what is extra in this? You have amino group. So you add excess ammonia. When you add excess ammonia, I'm writing ammonia as H and H. So this H and Cl comes out as HCl. This group goes and adds here. Benzamide. Now we very well know we have used benzamide which reaction in Hoffman's rearrangement reaction. Hope you would have seen Hoffman's bromide reagent or Hoffman's reagent. So use that Hoffman's reagent, that is your bromine, in the presence of your base KOH or NaOH, not a problem. When you are using Hoffman's bromide reagent, you are going to get aniline and the leftover KBr and all those, that's fine, not a problem. So this is how you're going to do the whole reaction. The simplest way I should tell you, learn this properly. First bromine, Grignard's acid, acid chloride, amide and amines. Done. Let's come back and see the last one. Benzamide from aniline. Okay, I have to prepare aniline from benzamide. Take this benzamide. This is your benzamide. Same thing. See here, the last one. Here I simple. I can add bromine. I can also add KOH. If I add KOH, 4 moles. I did this earlier. If I can add 4 moles of KOH, what do I get? I'm going to get K2CO3. Okay, first let us write what is this reaction. This is Hoffman's bromamide or Hoffman's degradation method or Hoffman's bromamide reaction. So first out of 4 potassiums, I did this video already. So for 4 potassiums, you will get one as K2CO3. Again, you have KBr. You also have water. And the leftover is your amine, aromatic amine. So this will be 2. Okay. This is how you are going to convert the reaction. Let's come back and do one more concept. This is your, basically all the questions of your, whatever you have studied, based on different physical properties, chemical properties, will club together and study using different examples. So let us see certain FAQs in your amines chapter. I'll be clubbing all the concepts of the chapter and are making you practice for the exam. Now let's see this question. Arrange the following in the increasing order of basic strength. Okay, different examples given to us. Let's see. Now what did they ask me? This is their concept, increasing order. Here, what did they ask me? Decreasing order. That means when I'm trying to arrange these particular compounds, I have to be careful. The last one should be maximum basic, and this is minimum basic. This should be concept. Here, arrange the following in the decreasing order. The first should be maximum basic and the last should be minimum basic. Remember this and start. Now I already said whenever you're finding when you have to answer a question like basic strength, what should you remember? Important thing, always the order would be aryl amines are less basic than alkyl amines. And more important thing, if you have an electron withdrawing group, as I've given, like nitro groups that are less acidic than aryl amines. So this is the sequence. Let's start. Here this is your aromatic ring. This one. You have 2 alkyl groups donating this compound. You have more alkyl groups donating. This one methyl group donating. Yes, done. Now, what did I say? This is your order. First would be, are we finding any EWG groups here? No. All are electron releasing. Important thing, more of electron releasing groups like your CH3, C2H5, OCH3, like that, greater is the basicity. This is your concept. Why? Because they keep on donating electrons. This will donate, this will also donate. This whole electron cloud is, the whole electron density increases in nitrogen, so that it can easily release that electron and become more basic. Then this is your concept. This is one concept, this is two concepts. Now let us come back and see, make it easy now. This one, least, according to this concept. Because of this is trying to drag the electrons, EWG group, and into which the electrons participate in resonance. Done. Next comes, have to compare between this and this. Here you have again a benzene ring. So benzene ring will be less. I have to compare between this and this. Here you have two alkyl groups. Here you have one alkyl group. So electron density here would be, this is further lesser than, because C2H5 is a maximum having two alkyl groups donating. That's it. This is how you're going to write the order. This is easy, very easy concept. Please try to understand. Minimum basic, maximum basic, because of our alkyl groups. Let's come back and see. Here, write the structures. Aniline, para-nitroaniline, para-toluidine, this, according to this sequence, arylamine, least basic. Okay, now you have an electron withdrawing group. You have to be very careful. Now this is your arylamine, this is your electron withdrawing substituent, this is electron releasing substituent. Now come back to the sequence. First, least basic would be EWG. So what should I write? Maximum should be here, least should be here. So EWG group is least basic. Done. Next, I have to compare between this and this. The maximum basic in these two are what? This one, isn't it? Toluidine, because of EWG group, ERG group, it's donating electrons. So I should write with symbol greater. The leftover is aniline. This is greater. So I hope you can understand the reason. You can write the reason here. I've already written, because of electron releasing group, more of electron density. Point number 1, electron withdrawing group reduces electron density. That's it. This is your concept. So please practice it. The concept is clear, and this is how you're going to answer. Once you write, try to put it in a box. That's it. This is your concept.